created a brand new account because you won't have any repositories. But just look for a new button to create a new repository. You can also go up here, I believe, and select new repository. So I'll select new. And then we have to give our repository name. You can give it any name you want. I'm just going to give it a dummy name. So this is going to be example fast API, but name it after whatever your project is. Technically, I've already set up Git for my project, just so I can track all the changes I've made throughout the course. But I want to make sure that I can walk you through this if you've never done it before. You can give it an optional description, and then you can choose whether or not a repository is public or private. If it's public, anybody can see it. If it's private, then only you can see it. We're going to keep it as public. Don't worry, if you decide to change it in the future, you can change it to private. However, it does make a few things a little bit easier when it's public. So I'm going to leave this as public, and then we're going to leave all of these unchecked. They don't really matter. And we'll select Create Repository. And then you'll see that it's going to give us a couple of steps to follow. So if we haven't already set up Git for our project, these are the instructions we're going to follow. And if we've already set up Git in our project folder, then we can follow these steps. However, we haven't set up Git yet, so we're going to, for the most part, follow along here. But we're going to modify it just a little bit because we don't need to run some of these commands. So go ahead and open up your project in VS Code like you normally do. Then open up your terminal, and we're going to follow these steps, but we're going to ignore the first one. We don't need a README for now, but we are going to do a git init, which is going to initialize Git for our project. And so make sure you're at the root directory of your project. So whatever this is called right here at the top, make sure that's where you're at, and just do a git init. That's going to initialize Git. And you may not see anything different about your folders, but I think it's because VS Code actually hides the Git folder. But when you actually did a git init, if you open up this your project directory and you click on view here and then make sure you select hidden items, you'll see that it created a .git folder. So this is where it stores all of the Git information. Then we're going to skip this git add readme. Instead, what we're going to do is we're going to run git add --all. So this is going to add all of the files that we have in our directory into Git. All right, and you'll get a couple of warnings potentially. Don't worry about that. Those won't create any issues. Then we have to commit our changes. So anytime you add a file, you then have to commit it. So we'll say git commit -m. So the -m means we're going to provide a message. So you usually give a message for each commit to kind of describe what changes you're making. So we're just going to call this initial commit. All right. And you'll see that we probably get an error if this is the first time you've ever worked with Git. And that's okay. It's just telling us, hey, we need to set up our user for our account on this machine. So we're just going to run this command right here, and then we're just going to provide the email that we use to register for GitHub. So I'll say git config --global user.email. All right, we set that, and then it's telling us to also set our name. So we'll do that as well. Then we're going to run that same command, the git commit. So if you just hit the up arrow a couple of times, you'll get to that. All right, so we've committed those changes. Then what we need to do is we need to set what our branch is. So here, this is just going to set our main branch to be called main. And so we can copy that, paste it into here. Then we have to set up a remote branch. So this is what's going to allow us to store all of our code on GitHub. So we're just saying, like, hey, listen, this is going to be the remote Git repository, and we just provide a URL to it. And so that if you take a look at the URL, it's going to match up with this. And in this case, we're naming it origin. You can technically call it anything you want. So we'll add that. And then finally, we need to do a git push -u origin main. And so this means we're actually going to push all of our code up to GitHub. And you'll see a pop-up asking you to sign in. And there's a couple of things we can do. We can get a personal access token, or we can sign in with our browser. So I'm just going to sign in with our browser. And we just select authorize right here. All right, and it says it's succeeded. So we should be able to go back, and we can see that a couple of things changed. So it looks like, well, that's our authentication. And then you can see that we're pushing all of this stuff up to GitHub. And so at this point, you're pretty much done. All of your code is now stored in GitHub. And we can just verify that by going back to this page and just select the name of the repository again. And you'll see all of our code stored on GitHub now. So at this point, our repository is set up, and we can move on to deploying our application. in this lesson, we're going to take a look at the first of two deployment methods that we're going to cover in this course. So what we're going to do is we're going to deploy our application to a platform called Heroku. And the reason I wanted to make sure to have this as one of the deployment methods was that Heroku has a very generous free tier. And so we can create an account for free and we can deploy our application absolutely for free without having to pay a single dollar, and we don't even have to provide our credit cards. And I wanted to make sure to add that just because I know for some of you guys that isn't exactly an option. And I wanted to make sure that you can still deploy your application and show off to your friends and family what you have created. And you'll see that Heroku has made it very easy to deploy your application, and it's very easy to push out changes to your application. It's a fantastic platform, and I think you guys will learn a lot on how to actually deploy an application by making use of a platform like Heroku. So we'll take a look at how we can, make use of Heroku, learn about the Heroku CLI so that we can push our application to the platform and ultimately have anyone be able to access our API. Heroku has a lot of really good tutorials on how to deploy applications on their platforms, and they've got one for Python as well. So if we go to Google, just search for Heroku Python, and the first result is going to be their tutorial. It's going to walk us step by step on how to actually deploy our application. But before we do that, there's a couple of things that we have to do. First of all, go ahead and create an account on Heroku if you haven't already done so. It's completely free, so just provide your email and so on. Then there's two other requirements. We have to have Git installed on our machine, which we've already done. And then finally, we have to install Heroku itself. So if you go to the setup section right here, you're going to see the installers for all of the different operating systems they support. So just select whichever operating system you have and get the Heroku CLI installed on your machine. And after you get it installed, usually you have to close out any of your pre-existing terminals and reopen them to actually be able to access the Heroku command. If you have VS Code, a lot of times I've had to just close out VS Code altogether, not just close the terminals, but actually close out the entire application and then open it back up. But after you've done that, if you want to verify if Heroku was successfully installed, just go to your terminal and just type in Heroku -- version. And if it spits out a version, that means Heroku has been successfully installed. And after it's been installed, we want to log in. So we do Heroku login. And then you just press any key right here. And it's going to open up your web browser. You can just log in and then provide your credentials. All right, and then once you're logged in, you can just close out this window. We'll go back to our code, and you can see logging in is done, and we've logged in, and then that's my specific account right there. All right, and once that's done, we're going to go back to the tutorial. And we're just going to kind of follow along. So if you go to prepare the app, you can ignore this. So they give you like a demo application to kind of follow through the tutorial, but we already have our own app, so we don't need to worry about that. If we go to deploy the app, we have to run this command Heroku create. So we have to create an app within our Heroku account. So let's run that command. But before we run that, I'm going to do a Heroku create -- help. And we can see that one of the arguments is going to be the name of the app we want to create. And so if you don't provide a name, Heroku just gives you a random name, but I always like to use a more familiar name so I know that which app covers which one of my applications. And so I'm going to call this Fast API Sanjeev. And keep in mind, these app names are global. So if I deploy my app as Fast API Sanjeev, you will not be able to create an app with the same exact name. And that's because to actually access our application once it's deployed, the URL is going to be the specific app name embedded in there. So it has to be globally unique. So if it says your app name is already taken, then just try a different one, maybe add a couple of numbers at the end. It doesn't really matter what the name is. All right, and once we've created our app, the next thing that we have to do is, well, actually, before we even do that, I want to show you guys what it actually did. So there's a couple things that happen behind the scenes. And the first thing is if we actually log into our account, I'm going to log in right here. Right, we're going to see our dashboard. So in the dashboard, you can see the application that we just created. Right now, there's nothing interesting. Nothing's been set up with it, so we don't actually see anything. But the second thing that it also did was if I type in git remote, this is going to show all of the remotes that have been set up for our Git. And we can see there's two now. So there's Origin, which is the one we set up originally, and that's GitHub ultimately. But Heroku added a second one. And so this is ultimately how we deploy our application, because instead of doing a git push origin main to push it out to GitHub, we can just do git push Heroku main, and that's going to push out our code to the Heroku platform, and then it will then create an instance for our application. So let's go ahead and do that. We're going to do a git push Heroku main. And this is going to take a little bit of a while because it's got to, set up Python. It's got to do a few other things. It's got to install all of our dependencies before it can actually get our app up and running. So I'm going to pause this video and then I'll touch base with you guys once that's complete. All right, so our application has successfully been deployed, and you'll see that in the logs, Heroku actually gives us the URL of our application. So I'm going to copy this URL and we're going to just open this up in the browser. And if you let this run long enough, you're eventually going to see an error. So it looks like something in our application is broken. And this is to be expected because there's still a few more things that we have to do to actually get this set up. Because if you take a look at what we've done, we pushed out our code to Heroku, right? But Heroku has no idea how to actually start our application. What is the command? It just knows that this is a Python app, but it doesn't know what it is. It doesn't know that it's a fast API app. It doesn't know that we're trying to build out an API. It has no idea. And when we deploy to our development environment, we ran uvcorn and then, app.main and then app, right? But we haven't given that command to Heroku. How does it have any idea that our code is in main.py and that within the main.py file, we have our app instance stored in a variable called app? It has no idea. So what we have to do is we actually have to create a file that's going to tell Heroku what is the exact command that we want to run. So inside your root directory, so just kind of collapse all the folders. Inside your root directory, so just right click here, create a new file, create a file called a proc file. So I've already got this in here. It's going to be in the GitHub repo, so you can take a look at it and make sure you capitalize the P. And actually, if you take a look at the tutorial and we go to the next one, which is define a proc file, this is going to just explain what the proc file is, but the proc file just tells Heroku what is the command that we need to start our application. And so here we give it a process type. So since this is a web application that's going to be responding to web requests, we want to use the word web, and then we specify the exact command that we need to run. And so in my proc file, a couple of things have been set up. So we run the command uvcorn app.main and then app like we've done before. We're not going to pass in the -- reload flag because this is production. We don't want it to automatically reload on changes because there should be no changes. We do have to provide the host IP. So this is just saying that, hey, we should be able to respond to requests to any IP. So whatever IP Heroku gives us, this is going to accept it. Then the next flag is going to be the port flag. So what port should we run this on? If we don't provide a port flag, then it's going to default to port 8000 like it always has. However, the thing about Heroku is that they're actually going to provide us a port. So we don't know what this port is ahead of time. So we have to be able to accept this port regardless of what it is. And so it's actually going to pass this down as an environment variable. So anytime you want to accept an environment variable or reference one, you can just say $ and then curly braces. So we're really just saying we want to take whatever value Heroku gives us with the environment variable of port, and we want to assign it here. And then this is just giving it a default value of 5000 if they don't provide one. However, Heroku will always provide a support, so I don't think we even need that. And so after you make this file, you're then going to have to push out these changes to Git once again. And since I already had this file, there's nothing to change in my Git, so nothing will get pushed out. So I'm just going to just change some random code. I'm going to delete this 1, 2, 3, 4 here so that I can at least have some changes in my code. You guys will already have changes in your code because you added the new file. So then go ahead and do a git add -- all. So that's going to add all the changes. We're going to do a commit. And we'll give it a message of added proc file. And then we do a git push. And then what do we push to? Well, first of all, moving forward, we want to make sure that this is stored in GitHub. So let's do a git push origin main. This is going to push it to GitHub. And then now we want to actually push out these changes to Heroku so that we can actually get our application up and running. So we'll do a git push Heroku main. And once again, we have to kind of wait through this entire process. Okay, so it's now finished. Once again, we're going to go back to the URL it's deployed at. And I'm just going to do a refresh to see if we fixed our issue. And the fact that it's still spinning for this long most likely means that we did not fix our issue. But I already know the exact reason why this is. And so we will take a look at exactly what is causing our application to not successfully get deployed in the next lesson. Anytime your application isn't working on Heroku's platform, they have a really easy way of accessing logs. So we can say Heroku logs, and then I'm just going to do a -- help just to see what options we have. And so here we could specify the app, or we can just dump the logs for all of our apps. But what I'm going to do is I'm going to pass in the -t flag so we can tail the logs as things happen. So if I do a -t and we scroll up, you can see that we've got a couple of different errors. And so it looks like there's some issues with settings, which, is the Pydantic model that we've set up for retrieving our environment variables. And it's saying that there's a couple of validation errors for our settings model. And it says that, hey, look, we don't have a database hostname, we don't have a database port, password, or any of the other information. So there's some issue with our environment variables. And this makes sense because in development, we use our .env file to provide all of the environment variables into that settings model right here. And we pass that by specifying the env file. However, we did not check our env file into Git. Remember, in Git, we used the git ignore file to make sure we excluded that because we don't want to actually check that into Git. So how does Heroku know what all of our environment variables should be? Well, they have and so we actually have to add those environment variables either through the command line or through the dashboard. But before we can do that, we need to actually get a Postgres database because right now we don't have a Postgres database. So what would we even provide for database hostname and port and password and things like that if we don't have one? So let's create one. And once again, Heroku provides us with a free Postgres instance that we can have access to. And that's one of my favorite parts about Heroku is that now we have access to Postgres. So let's go to Heroku Postgres. And I'll just say tutorial. And this is going to take us to their dev center. So this is going to show us actually how to create a Postgres instance. And so Postgres is one of their many add-ons. If you want to actually go to their website and see all of the different add-ons they support a ton. If you want to read this add-on, you can get that added. But in this case, we want to create a Postgres instance. So we do Heroku add-ons, create, then the type of add-on, which means it's going to be PostgreSQL, and then plan name. So we are under the hobby dev, which is essentially the free one. And that's going to actually create a Postgres instance. So let's run this and just Control-C out of this. And let's just do a -- help real quick, just to see what other flags we have. And that should be fine. We don't need to actually provide any other flags. So let's run this. And Heroku is actually going to create our Postgres instance. And keep in mind that for Heroku to spin up a Postgres instance, it does take a little bit of time, but we can actually monitor that in our dashboard. So if we go back to my dashboard and do a refresh, you can see that this is the new Heroku instance. And I can just click on this and we can see some more information. It's going to open this up in a new tab. And if you want to, we can go into these settings. And here we can take a look at our database credentials. So if I view my credentials, you can see that this is the IP address my database lives on. This is the actual database name. So we don't get to create our own database name or our own database within Postgres. They give us a fixed name, and that's perfectly fine. And then this is going to be the username that we're going to log in as. This is the port it's running on. And then this is our password. And they also provide us the full Postgres URL if we want to use that. So now that we have this information, feel free to save this real quick. And I'm actually just going to do a quick screenshot and save this in my notes so that I don't have to keep bouncing back and forth. And now let's go back to our application. And if we go under settings, this config vars is where we actually provide environment variables to our Heroku instance. And by the way, Heroku calls our instance dynos, but you can use either term you want. And so you could see all of the config variables that have been set, and there should be nothing except for one. So when you add a Postgres instance to your application, what happens is Heroku automatically adds an environment variable called database URL, and it's going to contain the entire Postgres URL. And so we could go into our application and then update our code so that in the database.py file, instead of breaking things down like this, we can just provide one one specific URL and just put it in as settings dot, database underscore URL. However, I don't like to change my code. I like it just the way it is. So instead of using the default environment variable, we're going to actually break this URL out into multiple different environment variables. So just open this up and take a look at all of the environment variables that we expect by going into our config.py. So we need all of these set. So we're going to add one for database hostname. And from the URL, if you forgot what the hostname is, and actually, I'm going to just open this one up in a new tab and then open up, actually, I don't even need to open up this one. I just need to flip between these two. So the hostname is right here, but you can get it from this URL just by clicking on this icon and then just grabbing the IP address. But it's such a small little window. I hate having to do that. So I'm going to close that and just bounce between these two links. All right, so let's grab the hostname. And we'll add this one. Then the next one is going to be the database port, password, name, and username. So let's just write those out. Database port, database username, database password, and then database name. I think that's it. Database port, password, name, username. And then we have to add the stuff for our token. So we got secret key, algorithm, and then the last one. And then now we can provide in the values. So the database port, we can see from here, it's going to be the default 5432. The username, and then here we'll grab the password. And then the actual database name here. The secret key, I'm just going to use whatever we used in development. Not actually recommended, but I'm just going to keep things as simple as possible for now. But you can provide any secret key you want. And I'll say in production, it'll expire after 60 minutes. All right, and so now we've got all of our environment variables set up, and our Postgres instance is already up and running. So I think at this point, our app should work. So we'll try this out again. So now that we set those new environment variables, how do we actually restart our Heroku instance? Well, let's do a Heroku apps -- help. And let's see if there's a restart. So there's app create, destroy, and it doesn't look like there's a restart. So we can't actually use the apps argument to restart our application. Instead, we have to do Heroku ps -- help. So now we can see that we do have access to restart. So we're going to do Heroku ps restart. And that's going to restart our dyno, which is our Heroku instance. And once again, I'm going to do a Heroku logs -t to tail the logs. All right, and so now you can see those previous errors are gone, and we were now able to successfully run the startup command. And you can see that we actually got past a specific port of 34731. And so that's why we ultimately had to provide the port variable, because this will change every time we restart it. However, we don't actually need to use that specific port number in the URL that we need to access. So let's get our app URL, which I already forgot. And if you ever forget your URL, you can just type in Heroku apps info, then the name of the specific app, and then it's going to give you all of the specific information. So you can see this is actually where the Heroku Git is being stored. We can see that we have one instance in this case running the web, and then we have our URL down here. So I'm going to copy this. And you can see that we get message hello world. So it looks like things are working. If I actually go to /docs, let's test that out. And so now we have access to documents. I'm going to minimize that. So it looks like things are working. However, if I try to log in, whether it's either through the documentation or if I actually send a request from Postman, you're going to see that there's going to be some issues. So here I'm going to actually, I can't even log in. I have to create a user first because this is a fresh deployment. So let's go to users, and we're going to create a user real quick. And I'm going to just try this out and put in whatever name you want. Now, so this is sanjeev@example.com. My password will be password123. We'll execute it. And you can see that we get an internal server error. So what is happening? Why can't we exactly create a user? Well, like usual, we're going to go back to our logs and we're going to see what happened. All right, so we can see the SQL that's getting inputted in the logs, and it looks like there's some kind of error with the SQL. And I don't know if that's going to give us a more specific error that's going to actually help us. I think that's all it's going to provide us in this case. But I think you guys can guess exactly what's happening. We deployed a brand new instance of Postgres. But right now, if we actually connect to our Postgres, you're going to see a few different issues. So I'm going to actually connect to this Postgres instance. And to create a Postgres instance, just right-click here and then select Create Server. So this is going to allow us to connect to another Postgres. And I'm going to call this Heroku-Postgres. And then here we're going to provide the same exact connection information. So we'll go back to Settings. We'll get our credentials. Okay, and so now we are successfully connected to our Heroku Postgres instance. And if I just drop this down and then go into databases, you'll see a ton of different databases. Keep in mind, we won't actually be able to access most of these. So the reason Postgres is able to, the reason Heroku is actually able to provide this for free is that they have one instance of Postgres, and then they give you one database within that instance that you can access, but only you can access that specific database. And so our database is D58. And I don't know if there's an easy way to search for databases. Let me see if I can right-click this. Nope, it doesn't look like there's an easy way, so I'm just going to have to scroll down to D5. And then what are the next letters? D5, 8RE05. All right, so I finally found my database. You'll see it's the one that I have access to, so it's actually colored. And if I just open this up real quick and go into schemas, public, and then tables, there's nothing in there. So that's really the reason why our application is not working, is because we have a brand new Postgres instance, but we haven't actually set up our tables or our schema. And so this is where Alembic is going to come into play once again. You'll see that since we already have all of our revisions set up, getting our production database to match our development database will be as simple as just running one simple command. So we'll take a look at that in the next video. In our development environment, we used Alembic to manage our database schema. So Alembic was responsible for creating all of those tables. And since we have all of these revision files within the Alembic folder, we can essentially track all the changes that we make. And so to actually get our development database up to date, we just ran Alembic upgrade head. And that would go to whichever one of these is the latest revision and make sure that our Postgres instance matched whatever that is. In our production database, because in our production database, it's going to be no different. We're going to just run Alembic upgrade head on our Heroku instance, and that's going to ensure that our Postgres database gets updated to our latest schema. And because we've checked all of these files into Git, because all of the Alembic folders was added to Git as well, that then our Heroku instance has access to all of our revisions. And so when we run Alembic, Alembic can keep track of all of those changes as well in our production server. And it's important to understand that we never run Alembic revision on our production server. We only run Alembic revision on our development server when we're staging out these changes. In our production server, whenever we want to push out those changes, we just do a git push. So we push out the code, all of our code changes, as well as all of the Alembic revisions to our production server, and we just run an Alembic upgrade head. It's as simple as that. So let's do that now. The first thing that we need to do is we got to figure out how do we actually run a command in our Heroku instance. I think your first guess is probably going to be, do we add another line into this proc file that we can kind of call whenever we want to? Not exactly, although maybe you can do that. But if we go back to our tutorial and go to start a console, we can run a specific command on our Heroku instance by doing Heroku run and then the specific command that we want to run. So let's try that out. And you can even drop into the bash shell. So there's a lot of flexibility, but we're going to just do a Heroku run, and then we want to provide the command that we want to run. I'm going to put it in quotes. I don't remember if it's a requirement to put it in quotes, but I'm going to do that just in case. So we'll do Alembic upgrade head. All right, and you see that it's running that command right now. And take a look at the logs, right? You can see that not only did it get our Postgres instance up to the latest revision, it has all of the other incremental steps added in as well, so we can roll back to any of them just like we did in development. And if we go back to pgadmin, I'm going to just refresh tables. And if we go to our tables, you can see that we have all of our tables here now. And just in case, because I believe we crashed our application maybe when we tried to, create a user without having a Postgres database or table set up, I'm just going to do a Heroku PS restart again, just to restart the instance, just in case. And now I want to go back to here, and we're going to just go back to the root URL to see if that works. And that works. That's perfect. We'll go back to docs. We can see that that works. Now let's try to create a user. And so I'll do try it out. And I don't even feel like changing any of these values. Technically, these should still work. So let's just try that. And we got a response back. And look at this. We got a 201, and we can see the user that was created. So it looks like our application was now successfully able to access our database. If we go into the users table, right click on this and just do a view, edit all rows, we can see the one user that we created. All right, and so that's pretty much it. We've successfully deployed our application. The last thing that I want to show you guys is how do we push out changes to our application? So let's say that I go into my app, and right now I go into main.py, and I see that this just says message hello world. And let's say I make some kind of change. And let's say I just add a whole bunch of exclamation points or something. Just keep it simple just to show you guys, regardless of what change you make, the steps are going to be identical. So we make some changes. The next thing that we have to do is we actually have to push out those changes. So first of all, you're definitely going to, push out those changes to your GitHub repository. So we'll do git push origin main. So that's going to push it out to GitHub. Well, sorry, I forgot to do a git add -- all. So we actually have to add those changes and then commit those changes. So we'll do git commit. Then we'll do a git push origin main. So that's going to push it out to GitHub. And then finally, to actually push those changes out to our production environment, we'll do a git push Heroku main. All right, and so that's pushed out now. And if we go back to our application, I'm going to go back to the root URL, and we can see that we now have the extra exclamation points. So we have successfully pushed out our changes. All it took was just one simple command. And keep in mind that if you make changes to your code, that's all you have to do. However, if you make changes to your database, so you go into Alembic and you create a new revision, then we have to follow the same exact steps. But on top of that, we have to do the Heroku run Alembic, upgrade head so that we actually push out those changes to the Postgres instance. But there you guys have it. You have successfully deployed the application that we have spent building the past couple of days. And so feel free to show this off to your friends and family. Feel free to make as many changes and modifications, really start to play around with it. Try to expand on the functionality of our application and just keep learning, I guess. For the second method of deployment, we're going to see how we can deploy our application on an Ubuntu server. And it's important to keep in mind that it does not matter where you host your Ubuntu server. You can run it on any of the major cloud providers, AWS, Azure, GCP. You can run it on DigitalOcean. You can run it on your local machine. Yeah, if you have VirtualBox installed on your computer, you can run it on Raspberry Pi. It doesn't matter. The steps are going to be identical as long as you run it on an Ubuntu server. Now, what we're going to do in this course is I'm going to show you guys how to deploy it on DigitalOcean, just because it's $5 a month. It's cheap. It's a fixed price. If you deploy it on AWS, then the price is it varies. And if you run it all month long, then it could spike up well past $5. So this is kind of the cheapest solution. But keep in mind, like I said, the steps are identical regardless of where you deploy. I just want to focus on making sure that you guys understand the steps that needs to take place to actually set up your Ubuntu server to be ready to host your application. And so if you don't have a DigitalOcean account, go ahead and make one. And then once you log in, you'll see this window. And what we want to do is select Get Started with the Droplet. So we'll select that. And what we want to do is we want to select Ubuntu 20.0.4. That's the latest version at the moment. If you're watching this in the future, you could probably grab one of the newer ones. Most of these commands are going to be identical. But if you wanted to make sure that you don't run into any issues, select the same exact version. Then for the CPU options, you want to select regular Intel with SSD. That's going to be the cheapest. And then you want to select the cheapest one right here, which is $5 a month, or 0.007 per hour. What is that? 7/10 of a cent? All right. And then select your data center. So I'm just going to select whatever's closest to me. I'm on the East Coast, so I'm going to select that. And then nothing else for the most part really matters. We can leave everything as default. And then you have two options for authentication. You can use SSH keys if you're familiar with how to work with that. If you're not, then start out with password for now. It's just a little bit simpler. And you'll see that DigitalOcean has some strict requirements for passwords. So you're probably going to have to try this a couple times before you find one that actually matches their criteria. And then here we can just give this a specific host name. I'm just going to call this Ubuntu-Fast API. It's nothing more than really just a tag. And that's all we have to do. We'll select Create Droplet, and DigitalOcean will create our Ubuntu VM. All right, and once the loading bar finishes, you should see a public IP. This is the IP that we're going to use to connect to our virtual machine. And so we'll take a look at how to connect to this in the next video. To connect to our Ubuntu virtual machine, we need to open up our terminal. So just search for terminal on Windows. If you're on Mac, you can do the same thing. Just search for terminal. And then on Windows, you can select command prompt. I installed another terminal, so I'm actually going to use that, but you can use this one as well. You can even use the built-in terminal within VS Code. It's all going to be the same thing. Okay, and to connect to a device, we have to use a protocol called SSH. So we do SSH, and then we have to provide the username that we want to connect to the device. And so this is going to vary depending on where you're deploying your virtual machine. On DigitalOcean, they're going to create an account for the root user. So this is like the most privileged user. This is where you can ultimately do anything with the device. You have unlimited access. So we're going to do SSH root @ and then you do the @ symbol, and then we provide the IP address. So I can just hover over this, select copy, and then paste it in here. And at this point, you'll get this, fingerprint message. So just hit yes. And then it's going to ask you for the password. So this is the password that we provided when we created the virtual machine. And at that point, we are now successfully logged in. And so you can, if you run ls, this is just going to print out the contents of your current directory. And so it looks like we've got one folder in our directory right here. But this is our Ubuntu virtual machine. And anytime you get a brand new Ubuntu virtual machine, the first thing that we want to do is we want to update all of the installed packages. So we want to make sure that it's up to date, right? This is just like installing any other operating system. And to run that, there's two commands that we want to run. So we do sudo. So this is going to give you, well, technically we don't need to run sudo because we're the root user, but if for some reason you're not the root user, then you always have to use the keyword sudo. So we do sudo apt update. And then the second command, we can do two and signs and say sudo apt upgrade. And then pass in a -y flag. The reason we pass in the -y flag is because if you don't pass in this flag, what's going to happen is it's going to do a few things and then a prompt will come up where you actually have to hit yes. And I always hate having to hit yes. When you pass in the -y, you can let it run and then you can just go do something else, go get some coffee because it is a fairly long process. If you get this pop-up, it doesn't really matter what option you choose. You can say keep local version currently installed or install the package maintainers version. I'm going to select this one, but it shouldn't make a difference. So once all of those packages are up to date, we need to install a couple of extra packages. And the first thing that we need to do is, well, let's actually check what version of Python we're running on this machine. So if I do Python -- version, all right, so it doesn't look like Python's installed. However, if I do a Python 3 -- version, we can see that we actually do have Python. It's just we have to use Python 3 because a version 3 of Python was installed. And so if you see anything that starts at 3.8.10 or later, you should be good. However, if you want to, you can always do a sudo apt install Python, and then I think you could just do a dash and specify the specific version that you want. But you can figure out how to do that by taking a look at the Python documentation. 3.8.10 or later is more than good enough for us. So we have Python. The next thing that we need to do is we need to install pip. And let's actually double check and make sure that it's not already installed on our machine. So we could just say pip -- version. We could see there's no pip here. However, let's try a pip 3 -- version. And it looks like we don't have pip installed, but it's giving us a little hint on how to install pip. So we can do sudo apt install python 3 - pip. And we'll hit Y for yes. And once that's done, we're going to use pip to actually install virtual NV because we are going to make use of virtual environments on this machine as well. So we'll say sudo pip 3 install virtual NV. And so now we should be able to use the virtual environment command. The next thing that we have to do is install Postgres on this machine. So we'll run sudo apt install, and then the libraries that we need are PostgreSQL and PostgreSQL-contrib. And then we'll do a -y so that we don't have to hit yes. Okay, so we've got Postgres installed. How exactly do we connect to it? So what we're going to first do is before we try to connect to it from our local machine, I want to connect to it from the actual Ubuntu computer itself, the Ubuntu virtual machine. And so we're actually going to take a look at the CLI for accessing the Postgres database. And so the tool that we use to do this through CLI is called PSQL. Right? And we should be able to have access to it. So if you do PSQL - version, you should see that it should respond back with something. So that means PSQL is installed. And if I do a PSQL - help, it's going to show us the different flags that we can pass in. But the main flag that we want to pass in is the -u, so we can specify what's the username that we want to connect to. So let's say PSQL, then -U, and then our username. And we know that when we install Postgres, it's going to install a user on the database called Postgres. So that's what we always use to connect to it by default. And so we say Postgres. And if you want to, you can specify the specific database you want to connect to. I believe there's a flag. It might be -d. Yep, the database name. So you could technically say -d Postgres, but Postgres is going to be the default, so you can leave that off. And we're connecting to our local host, which is going to be the default as well, so we don't need to pass in that. And the port, we can also pass that in. The default is 5432, which is what it's running on. So we don't really have to touch anything else, and we're going to try and connect like this. So let's see what happens. All right, and we get this error. It says a PSQL error, fatal peer authentication failed for user Postgres. So for some reason, it's saying peer authentication failed. And this is a special meaning, right? It sounds like a regular login failure, but it's not. And it's because Postgres, when you install it on Ubuntu, it has a special way of authenticating users by default. So when it comes to local authentication, and what I mean by local authentication is the Ubuntu VM connecting to the database itself. That's what a local authentication means. Whereas if I'm connecting from my Windows machine to the Postgres database on this Ubuntu VM, that is not considered local authentication. So since we are on the same machine that we're trying to connect to our database, Postgres considers this a local authentication. And on Ubuntu, we have a special configuration called peer authentication. Now, this is the default configuration for Postgres. And what peer authentication does is it actually takes the user that's logged in to the Ubuntu machine and it tries to log in as that user, essentially. So even though we pass in the -u flag, since I am technically logged in as the root user, all right, Postgres is going to error out because it will only allow a Ubuntu user called Postgres to be able to log in as the user called Postgres on the Postgres database. A little confusing, right? But it actually obtains the username from the Linux kernel. So whoever you're logged in as, that's the only person you can log in as. And so what we can do is, first of all, because this is the default configuration, Postgres understands that. So Postgres actually created a user on our Ubuntu VM called Postgres. So if you want to see the list of all the users on your Ubuntu machine, you can do a sudo cat /etc/passwd. And you can see all of the users that have been installed. And you can see that it actually created a user called Postgres on this machine. So I'm going to change that user. So we can do that by doing su dash and then the name of the user, so Postgres. Right? And notice how we changed to this specific user. And so now if I try to do psql -u Postgres, we can now log into the database. So if you see this, that means you're successfully logged into the Postgres database. And while we're logged in here, before we do anything else, because first of all, we're going to get rid of that peer authentication because I hate it. We want to create a password for our Postgres user. And to assign a password to this user, we can say \password, and then the name of the user that we want to assign a password to. So we're going to use the Postgres user. And then here we're going to provide our password. All right, and so now we should have a password. And I'm going to exit out of here. So to exit out of the Postgres console or terminal, whatever you want to call it, you just do / and then Q for quit. And then we're still logged in as the Postgres user. And so if you type in exit, it's going to take us back to the root user. There's going to be a few more things that I want to change to our Postgres installation. And so anytime you want to modify the configs for Postgres, what we want to do is we want to move to a different directory. So the command to move to a different directory is cd. And then we specify the path to the directory. So we want to go to /etc. So generally, any application you install on Linux or an Ubuntu machine, usually the configs for that package or that application is going to be in /etc. And then here I'm going to say Postgres /. And then if I hit tab, you can see that it's going to autocomplete. So you're going to specify whatever version of Postgres you ran. And so in this case, I have Postgres 12, but if you installed a version 13, then you would put in, it would be a folder called 13. And then we will go to main. And if I type in ls, we'll see all of the files that we have in this folder. And the two main files that we want to focus on are pg_hpa_conf. So this is where we configure Postgres, as well as postgresql.conf. And so we're going to open up postgresql.conf. So I'm going to say sudo vi postgresql.conf. And we want to kind of scroll down. And we want to take a look at the connections and authentication section. And so if you take a look at the default configuration, we can see that under listen addresses, it's only going to allow localhost to connect to our database. That means only when we're logged into this Ubuntu VM can we then log in to this Postgres database. It is not going to allow me to take pgadmin on my Windows machine and connect to it remotely. And so I want to change this. And technically, you don't have to do this, but if you do want to be able to connect to it remotely, then you want to change these configs. And so I'm going to put this config, we're going to say listen_addresses equals. And then here you would provide the IP addresses. And so, if you wanted to only be able to connect to this database from, your office, then you would put the IP address or domain name of your office. If you want to allow all IP addresses to connect to it, you would just do a star. So that's what I'm going to do. It's going to allow me to connect to this regardless of what computer I'm on or where I am on the network. However, it generally, when it comes to best practices, you want to really narrow down the scope of the different IPs and domains that can access your database, because that's the most important part of your application. You want to make sure it's as secure as possible. All right, so we'll save this. That's the only change we need to make in this file. Then the next file that we need to change is pg_hba_conf. So we'll do the same thing, sudo vi pg_hba_conf. And we're going to scroll down. And we're going to take a look at our default configuration. So I did mention that when we connect locally, it uses a peer authentication. So you can see that for local connections, and I forget what the second column is if we actually scroll up. Well, I got to go up. Actually, let's see what the second column is. Okay, so this is going to be the format of it. So this is going to specify what type of connection, then what database this connection should be associated with, or this rule should be associated with, what's the user, and then what's the method. Well, we also have address and method if you are connecting remotely. So we want to change this. So we want to say for local users, regardless of what database they connect to and what user they connect as, we want to make sure that we do not use peer authentication. We use regular password-based authentication, which is MD5 in this case. And so here, we're just going to change this. So this is saying for any database, this rule is going to apply. For the user Postgres, we're going to say, instead of peer, we want MD5 like we have here. We'll say MD5. And we're going to change this one to MD5 as well. And then lastly, for these two sections right here, these are going to be for remote connection. So if I want to connect from my Windows machine, this is the rule that's going to apply. So this is saying that for hosts, for any database, any user, right now the only IP addresses that can connect to it are going to be 127.0.0.1, which means localhost. So that's effectively blocking all remote connections. So I'm going to go here, and we are going to change this. And I'm going to say 0.0.0/0. So this means any IP address. And then just to keep things nicely formatted, I'm going to move that over there. And then we're going to do the same thing for IPv6, which is what this line is doing. And I'm going to say this. So this is the syntax in IPv6 for saying any IP address. And that should be all of the config changes that we need to make. And so I'm going to exit out of here and make sure to save it. All right. And at this point, you probably think the changes have been made. However, generally, when you change any configuration file, you actually have to restart the application for the changes to take effect. And so to restart an application, you do systemctl restart, and then the name of the application. So this is going to be PostgreSQL. All right. And it should be running at this point. So let's try this out now. Right now, we are still logged in as the root user. So remember, before we actually had to change to the Postgres user on our Ubuntu machine before we can log in as the Postgres user. So now instead, I'm going to do PSQL-U Postgres. And I want to see if I'm able to log in. And so now I actually get a prompt for a password. So it looks like things are working so far. So I'll try my password. And now we are successfully logged in to our Postgres database. That's perfect. Now let's actually try to connect to it using pgadmin. And so pgadmin, I've got my local machine, which is right here. If I want to add a new machine, I'm going to right click on servers. We're going to select create server. Give this a name. I'm going to call this fastapi-prod. Call it whatever you want. Connection details. Here we're going to provide the IP address. So I already forgot what's the IP address of our machine. We logged in 134.122, whatever that is. We're going to provide this. That's the default port. That's the the user we're going to connect as. And then if we want to, we can put in a password here as well. All right, and now we are successfully logged in to our production database. If I open this up, take a look at the databases, we just have the one default database that always gets installed. Till now, we've done everything as the root user, and it's generally frowned upon in the Linux world, regardless of what flavor of Linux you're using. It could be Ubuntu, CentOS, Red Hat. You generally don't want to be logged in as the root user because it opens the door for potential security vulnerabilities, and it opens the door for you to potentially break your machine. And so what we're going to do is we're going to create another user. This user is going to have root privilege, so he'll still be able to make any of the changes, but it's better than being logged in as the root user. And more importantly, when we actually install our API, our Python application, we're going to have our non-root user be the one responsible for starting it. We don't want the root user to start the application because then we're giving our application root access to our machine, and that is very risky. So instead, we want a non-root user to start our API. So on Linux, to create a new user, you type in the command usermod. Sorry, not usermod. We do add user and then the name of the user. So pick any name you want. I'm going to do Sanjeev in this case, but you can name it like Fast API or whatever you want. And then it's going to ask you for a password. So put whatever password you want. And then you can provide your name, but none of that really matters. And just hit Y here. And so we've now created a user. And what we can do is, if you want to, you can do a su dash and then Sanjeev. And then it's going to move you to the Sanjeev user. Or what you can do is you can exit out of this connection and then exit out of here altogether. So now we're back on our local machine. And instead of when you do an SSH root at whatever, you can change this to the new user that you just created. And so that's going to log you in directly as that user. Now, this user by default doesn't have root access. So if I try to do, sudo apt upgrade, right, it's going to ask for sudo password for Sanjeev, and I'll put my password in and take a look at the error that we get. It says Sanjeev is not in the sudoers file. This incident will be reported. So anytime you create a user, you have to give him sudo access or root access so that he can actually perform operations that require root privilege. So we're going to have to exit out of here. Once again, I'm going to log back in as the root user. And to give a user root access, we run the command usermod, and then we pass in the flag -a and then capital G. Make sure it's capital. And we say sudo and then the name of the user. So I created a user named Sanjeev. So I'll just put that in. And so at this point, the user Sanjeev has root access. So let me exit out of here again, and we're going to connect back as the user Sanjeev. And so now I'm going to run sudo apt upgrade. And so if I try that, put my password in, you can see the command run. So we now successfully have root access. If you type in pwd, this is going to tell you the exact directory that you're in. So I'm in a folder called /home/Sanjeev. So whatever your username was created as, right, your default home directory is going to be /home and then your username. And so while you're in your home directory, and if you don't know how to get to your home directory, you could just say cd and then tilde. So that's going to take you to your home directory, or you can do cd/home and then your username. That's going to take you here. Whoops. All right. So once you're in your home directory, what we're going to do is we're going to create a folder for our application. Technically, you can put this anywhere on your machine. I'm just going to put it in my home directory. So I'm going to call this folder app, or we could call it Fast API. It doesn't really matter. So I'll say mkdir. This is the command to create an app. Create a directory. I'm going to call this app. And then to move into that app, we do cd app. And within this folder, what we're going to do is just like we did on our local machine, we're going to create a virtual environment. So I'm going to say virtual env, and then we'll call our virtual environment venv. All right, and then if I do an ls -la, let's just make sure I created the virtual env folder. Then to activate our virtual environment, we'll type in the command source. Then we go into that folder, the bin folder, and then the activate file. All right, and then we should see this little nugget right here. So this is going to let us know that we are currently in a virtual environment. And if you ever want to get out of the virtual environment, you can just say deactivate. Within our app directory, we're going to create another folder called source. So this is going to contain all of our source code. So we'll cd into the source. And now what we're going to do is we're going to copy all of our code onto this machine. And so how do we do that? Well, since we already have it stored on GitHub, all we have to do is just go to the URL for our repository. So this is my repository that I created. This is the main one called FastAPI-course. This is public, so any of you guys can access this. But you're going to go to your specific repository. And once you get to the repository, this is going to be the URL. Or you could just select code right here, and then this is going to give you a little link to copy. So we could just copy that. And then we can go back here, and we can say git clone, paste that in here. And then before you hit enter, hit space, and then dot. So that's going to install it in this current directory, and it's not going to create another directory that's the name of my repository, which is kind of annoying. I don't actually want a directory called fastapi.course. So we'll hit that, we'll run it, it's going to clone it, and at this point, if I do an ls, we should see all of our specific code. Great. Now, before we do anything else, let's reactivate our virtual environment. So we'll say source venv libbin activate. All right, we've got our virtual environment set up again, and we're going to move into our source directory. And if you recall, remember, we don't have any packages installed, so we don't even have FastAPI installed, but we do have our requirements.txt file. So if I just cat that real quick, if you forgot what that was, that's going to tell this machine exactly what version of every single dependency we need to install for our application to work. And so we can just install all of those with one command by doing pip install -r requirements.txt. All right, so I got an error, and this was expected on my end because when I was running through this, I ran into this error. And so if you see this error right here, anytime you see red, it's never good. But what you want to do is you want to go right about here where it says include and then libpq-fe.h. This is implying that we're missing a package that's probably called libpq. If you actually search this error, you're going to get the same result. So if you run into this exact issue or even another issue, just look for the library mentioned right here where it says that include line, right? And just search for that library and just see how to install it. Okay, so since it said we're missing this library, I'm going to do it's not actually a pip install. We actually have to do an apt install. So we do sudo apt install. And actually, before I even do that, I'm going to deactivate my virtual environment, and we're going to do a sudo apt install libpq-dev. All right, so now that we've got that library, that missing library installed, we're going to then go back into our virtual environment. And we're going to run that same command to install all of our requirements. And I have to move into my source folder. All right, and it looks like we have successfully installed all of our packages. The next thing that I actually want to do is let's go ahead and try to start our application. So we have access to UVcorn, so we can just do UVcorn app.main. So this is the same exact command that we ran on our local machine, and then app. We don't need to pass in the reload flag because this is our production server. So we would never want it to automatically reload on changes because no one should be making changes on our production server. So we'll run this and let's see what happens. Right? And it looks like we get 8 validation errors, which is to be expected because it looks like we are missing all of our environment variables. And that's correct. We never set our environment variables. So in the next section, we're going to take a look at how we can set up our environment variables on our Linux machine. Okay, so let's get started on creating our environment variables. So what we want to do is to create an environment variable on a Linux machine, we say export, and then we give the name of the variable. Here, this is just a demonstration. So I'm going to say my _name, and then we set equals, and then whatever value we want to give it. So you can give it anything. I'm just going to say this is Sanjeev. All right. So we'll hit that, we'll run that. And then to actually see if this worked, to see all of your environment variables, we just say print NV. And so this is going to spit out a whole bunch of default environment variables. And then to see the one we sent, just kind of look down, look for my name, and we could see that it was successfully set. So at this point, we could just go one by one and manually set all of these. However, that is a very inconvenient process, and I wouldn't expect you guys to do that because we've got 7 or 8, and any other project could have 10, 20, 30. So it's not really realistic to do that, one environment variable at a time. So let me quickly remove this environment variable, which you can do with the unset command. And so I could just say unset my underscore name. And if I do a print NV, we should see that it's no longer there. And what we're going to do is I'm going to go back to my home directory because I don't want to mess around in my application directory. I'm going to go CD and then the tilde, or you can do /home/ and then whatever your username is. I'm just going to do that. All right, so this is going to take me back to my home directory. And I'm going to create a brand new file. And if you want to create an empty file, you can just say touch. And then I'm going to just call this .env. All right, so we should, if I do an ls-la, we should have the .env file right here. And I'm going to open that up. And here I can provide a list of all of the environment variables. So I can say, and keep in mind, this has to be in the same exact syntax. So we have to say, just like we would put on the CLI, we would say export, then the name of the variable. So I'll say, my name again, which equals Sanjeev. And then let's do my underscore password, which is going to be password 123. So I can save this file and I can say source.env. So this is going to set all of those environment variables. So if I do a print NV now, we do have my name, and somewhere along here, yep, we've got my password. So that's another way of setting things. It's a little bit easier to kind of keep everything in a file. But what I don't like is that I have to put it in this format where I put export and then the environment variable. What would be awesome is if I could just somehow get it so that the environment variable file in my Ubuntu machine matches with the environment variable file on my local machine. I want to just be able to put the key and the value pair like here. And so that way I could just copy this, paste it into my production server, and just change the values there. And so we can actually do that. It just requires a little bit of a modification. So let's go back here. And I'm just going to unset both of these real quick. And we'll just double check it got removed. So they're removed. And we're going to open up the .env file. And I'm going to just delete everything. And what I'm going to do is I'm actually just going to copy this for now and just paste it in there. Let's just see if I can get all of this set from a file, and then we'll change the values later. And so when you have a regular file, like the one we have right here, where we don't have the word export in front of it, it does require a little bit more of a complex command, but all you have to do is you run this command. So you do set -o all export, then source, and then you provide the path to the file. So this is going to be in my home directory. So it's /home/Sanjeev. Just make sure you swap it out with your specific username. And then we provide .env. And then we say set +o all export. All right. And so now if I do a print NV, we can see I've got my database password, my database username, I've got my database port, hostname, and all of the variables that I set have now been set as environment variables. So that's what we're going to do. However, there's still one minor issue. If I exit out of here, or actually, sorry, not if I exit, if I reboot, and I actually have to do a sudo to actually reboot, but I'm going to reboot, and I'm going to show you guys that when you reload your machine, you lose your environment variables. So we'll give this about a minute or two to kind of boot back up. Although I find Ubuntu machines boot up fairly quickly, so let's just give this a shot, see if we can connect. Nope, not yet. All right, so I've logged back in after it rebooted. If I do a print NV, you're going to see that all of the environment variables that I set are all now gone. So how can we get all of these environment variables to persist through a reboot? Because if our machine goes down and comes back up, then we lose those environment variables, then our application's broken. Well, there's a couple of different ways that we can have environment variables persist through a reboot. One of the ways is, let's go to our home directory. I'm going to do an ls-la. And what I'm going to do is we're going to go into this .profile file, and we're going to set that exact command that we had run to set my environment variables. Where is that command? This one right here in that file. So copy this, and then just do a vi.profile, and then go to the bottom of the file, and below the last line, just paste that command in. And then we can just WQ. All right, and so this is going to cause, anytime we open up a session or a terminal, even through a reboot, it's going to run that specific command so that those environment variables are all set. Right now, if you do a print NV, you will see that it's not set, and that's to be expected because we were already connected to it. But if I exit out of here, reconnect, do a print NV, we can now see that our environment variables are set. And then just to prove to you that this actually persists through a reboot, we're going to reboot this machine. All right, so it's rebooted. Let's do a print NV, and we can see all of our environment variables are still set. So this is the method that I'm going to go with. Keep in mind, when it comes to environment variables, there are 1,000 different ways to tackle this. And so people like to set their environment variables in different ways. This is just the way that I've done it. This is the simplest way, but there are a number of different other methods. Some of them will probably be more recommended, better, but I want to keep things as simple as possible. The one thing I do want to kind of highlight is that our environment variable is stored in my home directory. It is not in the app directory where all of my application code is. And that's important to me because I don't want to put it in my application code because I don't want it to accidentally get checked into Git. I don't want anyone to accidentally see my production passwords or anything like that, because then my entire application is compromised. So I like to keep it separate by moving it into a completely separate folder so that there's no chance that it gets mixed up in my application code. All right, so since we can connect to our Postgres database, let's go ahead and actually create the database within this machine. So I'm going to select, right-click here, and I'm going to say Create Database. Call your database whatever you want. I'm just going to call it Fast API to keep things simple. And so now we have our database once we click on it, and so now it's up and running. And so since we have that information and we have the information for connecting to our actual Postgres instance on this machine, let's update these environment variable files so that they are accurate at this point, because I believe they're still pointing to whatever our production was set as. Sorry, our development environment. So here, the host name is still going to be localhost. The port, since I installed Postgres on the default port, we can keep that the same. You want to make sure you update your production password. I chose the same exact password just to keep things simple. The database name, we just created one called Fast API. Here, this is going to be the database username. If you want to, it is recommended to create another Postgres user. However, I'm just going to keep this as the default Postgres user to keep things as simple. You definitely want to update the secret key. The algorithm, you can leave that as default. And then the access token, I'm going to make this a little bit longer. Let's do 300 minutes. All right, and now let's reactivate our environment. So I'm going to go into apps, and then we'll do source VNV bin activate. So it's going to activate our virtual environment. And right now, you probably notice a little bit of an issue, and that is that we don't have any tables right now. You go to our schemas, and then we got no tables in here. Oh, sorry, we're in the wrong database. In the Fast API, we've got no tables. right? Nothing here. And so we have to set up all of our models now. However, since we are in our production environment and since we've set up Alembic, you'll see that this is dead simple. And when it comes to Alembic, it's important that in your production environment, you never create revisions in your production environment. You only create it in your development environment and you check it into Git. And since we checked it into Git, if we go to source and then go into our Alembic file folder and do an ls and then go into versions, we have all of our revision files. And so what we can do is we can just, sorry, I didn't mean to hit exit, got to log back in now. All right, make sure that virtual environment's enabled every time. I'm going to go into source. And what I'm going to do is I'm going to do Alembic. Upgrade. And then head. So this is going to set up our database and it's going to upgrade it to the latest revision. All right. And take a look at that. It created all of the individual revisions one at a time. So we could still roll back just the same exact way that we did in development. And with just a click of a button, we've got our entire database schema all set up. And we can just refresh this real quick and then go into our tables. And you can see that we've got our 3 tables plus the Alembic table as well. So now that we have our database all set, I think it's time we try to start our application again. So move into your apps directory. And if you haven't activated your virtual environment, do that again. Move into the source directory. And now we're going to run the same uvcorn command that we ran in our development environment. All right, so it says it's running on the local host IP address of this machine on port 8000, which is the default port. So let's try to connect to it. So what we have to do is grab this, and we're just going to paste the IP address into our browser, and we're going to do :port 8000. And let's see if this works. And it looks like it didn't work. So what happened? Well, the problem here is that we needed to make sure that it can listen on any IP address. So when you just set this to 127.0.0.1, that means only this machine can access it. So I'm going to Control-C out of this. So we're going to stop it. And we're going to pass in one more flag. We're going to say --host and then provide the IP of 0000. So we're going to listen on any IP that this machine is potentially running. And if you wanted to, if I did a --help real quick, we can also specify what port we want to listen on. So if I do --port, I can provide a different port so it doesn't go to the default port 8000, but I'm going to keep it as port 8000. You're going to see that it ultimately doesn't matter when we actually deploy, because we're going to deploy it in a way that it's always going to use either port 80 or port 443, which is the default ports for HTTP and HTTPS. So this is good enough. We're going to start it again. Now you can see it's listening on any IP, and we're going to refresh. And if you guys can't see that because it's tiny, we can see that I got message hello world, which is accessing that root path that we have. So it looks like things are working at this point. However, right now, if this program crashes, or if we reboot our machine, you're going to see that it doesn't actually restart automatically. And so what we're going to do is we're actually going to use a process manager. So we're going to use something called gunicorn. So Control-C out of that. Instead of just starting our application with uvcorn, we're going to use gunicorn. And if you haven't already installed it, which you probably haven't, do pip install gunicorn. And make sure you're in the virtual environment. And so gunicorn is going to be responsible for starting our application. Now, I've already got this installed because I added it to my requirements.txt file a little bit earlier. But if you haven't done that, that's fine because I haven't told you guys to do that. So just do a pip install gunicorn. And if you get any errors, most likely you'll need 2 other packages. You'll need pip, you'll need HTTP tools. And so you could just do a pip install of HTTP tools. And you'll also need one extra library, which is UV tools. So if you hit any other errors moving forward, right, go ahead and install those 2 libraries, HTTP tools and UV tools, and that should fix any errors that you have. So those were some potential errors that I ran into when I was kind of doing a quick test run. But at this point, we should have access to a gunicorn command. So I can say gunicorn, and let's just do a quick -- help just to see what options we have. And here, what's nice is that you can actually set the number of workers. So, if you're on a multi-threaded machine or you have a virtual machine with multiple CPUs, you could set up more than one worker so that they're all listening all at once, and then it's going to get load balanced across all of them. So we're going to set up 4 by default just to show you. You could set up 1. It doesn't really change anything. So the command is going to be gunicorn -w. So this is for the number of workers. We're going to say I want 4 workers. And then we're going to say -k. And we're going to say uvcorn dot workers dot capital uvcorn capital worker. All right. And then now we just specify how to start our application like we normally do. So we go into our app folder, we grab the main file, and then we start app. And then, just like we did with uvcorn a little bit while ago, we had to start it with the -- host and then do all zeros. Here with gunicorn, we have to use a -- bind, and then we do 0.0.0. And then we specify the port we want to listen on. So let me drag this so it looks a little easier to read. So we do that, and then the port that you want to listen on. Let's start that. And it looks like I got a couple of errors. So let's see what happened. All right. And so if you get this error, UV loop, it means we're missing a library. And so, like I said, if you get any errors, make sure you do the pip install HTTP tools. I should have this one already installed. And then you want to do a pip install UV tools. And I realized I've been making a mistake. It's not called UV tools. It's going to be UV loop. All right. And so now it's successful. So not UV tools, UV loop. I guess I got it mixed up with HTTP tools. And so you can go ahead and if you actually wanted to, if you did a pip freeze, you could go ahead and copy this and make this your new requirements.txt file that you check into Git. This is going to have gunicorn automatically in there because we already installed it. It's going to have UV loop, and it's going to have what is the last one that we needed? HTTP tools, which is right here. And so you could check this version into Git, and so that way it's all up to date. And so when you deploy to other Ubuntu machines or other computers, it's going to have all of these extra packages so you can deploy right away. All right, and now let's run the same gunicorn command. And now it looks like it started. It says it's listening on this port. And notice something interesting. Look at this. It actually started up 4 worker nodes, and you can even see the process IDs. So this is probably the parent ID, and then these are the little worker IDs. So if you wanted to, we can open up another connection. And I can do a ps-aef pipe grep. We could probably just grep for gunicorn. Yep. And so you can see all of the different processes that were started. And so there should be 5 of them. 1, 2, 3, 4, 5. One of them is the parent process, and then the 4 are the other child processes. All right, now that's working. Let's just do a refresh just to make sure we didn't break anything and it's still working. And so if we do a refresh, you can see that we can still access our application. And if I go to /docs, the documentation should still be there. Perfect. So it looks like our app is working. We can test it now by testing the individual endpoints, but we're going to hold off on doing that because we're going to make a few more changes. So the first thing is, right now, this is running on our specific terminal, and so it kind of locks up our terminal. I want this to be running in the background, and more importantly, I want this to automatically start up on boot, because right now if we reboot our box, right, we'd have to manually log into this device and run this same command. So we have to find a way to kind of automate it so that upon reboot, it's going to run the application, and we want it to run in the background so that we don't see any logs by default. And we'll tackle that in the next video. All right, guys, so in this video, we're going to figure out how we can have this command automatically run upon reboot, as well as how can we run this as a background process so that we don't hang our terminal. So what we're going to do is just do a Control-C to stop it for now. And what we're gonna do is we're gonna create our own service. And if you ever run systemctl and then either status or start or restart and then the name of some application that you wanted to run, that is an example of making use of a service. And so what we're going to do is we're going to make our own service, which starts this application here for us. And you'll see that it's actually pretty simple. If we go to /etc/systemd and then system, and I forgot to do a CD to move into that directory. If you do an ls, these are all of the services that have been installed on our machine. And we're just going to create a brand new one. So how do we create that? We have to create a couple of files. And I have actually created them for you guys ahead of time. So if you check my GitHub repo, you will see a file called gunicorn.service. And there's going to be a couple of things that we have to change. So let me just walk you through what each one of these lines mean. So under unit here, we're just going to give a description of what this is going to do. So this is going to be a gunicorn instance to server API. You can put whatever description you want. You can say demo, fast API application. Doesn't really matter. Now the next line right here where it says after network.target, what this is going to do is this is going to tell systemd or our Ubuntu machine when to actually start this service. And so it's saying that, hey, we need our network service running before we can start our API, because if the network's not up, then nothing else really matters. So we're going to wait for network to come up before we start this service. Then on the service, we're going to figure out, we have to specify what user is going to run this service. So we need this to be associated with a user. I created a user called Sanjeev, so I'm going to update this. And then for group, you want to just put the same exact name as the user. Then we have to specify the working directory. And so this is going to be the directory our service is going to be launched in. So go ahead and update this to point to the directory your app is running in. And if you don't know what that is, remember, just go home, then move into apps. And then you can go into the source folder if you want and just type in pwd. So that's going to get you the exact path that you want. And so I have to update this with my username. And then the environment. So because we want this service to run the gunicorn command, which is right here, we need it to run in a virtual environment. So to actually set the virtual environment through this script, we have to say environment equals, and then we set this path variable. And we just point it to the exact path to our bin folder. So once again, if you don't know how to get there, just go to your app folder, go into your virtual environment, go into your bin folder, and then just type in pwd, and that's going to get you the path. And so I just have to update this with my username. And you'll just do the same thing. You just have to update the username. Then we have to specify the exact command to run. So we have to provide the path to where the gunicorn command resides on. So it actually sits in the bin folder. So if you actually do an ls here, right, you can see the gunicorn command. And so that's going to give it the path to the command. And then after that, well, actually I have to update my username once again. Right? And after that, it's the same exact command that we ran before. So for workers -k, then we have this long command right here. And then we specify how to start our application, which is this command. And then we're going to bind it to 0.0.0. And then you can pick whatever port that you want. And this is just a default config. Don't worry too much about it. You need it, but I don't want to go too far into how Linux works to actually explain this. Just know that this is just a standard procedure for creating a service. So to actually create the service now, what we do is let's go to /etc systemd, then system. And let me deactivate my, we don't need to deactivate, it's fine. We're going to create our service file here. And so I'm going to do a sudo vi, and then the name of the service. So what do you want to call your service? So when you type in systemctl and then start, what's the name of the service you want to type in? You get to specify. I'm going to make it so that it's just called API. Very simple. You can call it fast API. You can call it social media app. It doesn't really matter. It's up to you, but I'm going to call it API. And since I want to call it API, I'm going to create a file called API.service. And then what we can do is just take this, copy it, and we will paste it in here. All right, and to test out our service, let's do a systemctl start API. And we're going to have to put in our password. And so this started our API. And if we do a system CTL status API, whoops, there shouldn't be a space, CTL status API, this should just give us the status of our service. We can see that it looks like it failed. That's not good. And it's going to provide us some logs. And if we take a look at the logs, you can see algorithm, field required, access token, expires, field required. So it looks like something is wrong with our environment variables, because we saw the same exact error when we were originally setting this up before we got the environment variable. So for some reason, it's not actually accepting these environment variables. And the reason for this is that the service file, the service that you create, doesn't have access to users' environment variables. And if you actually go back to our home directory, and then we go to ls, ls-la, remember we created this env file, and then we loaded it in the .profile. So the environment variables that get loaded from .profile aren't accessible within a service. And that's just the way services work. So what we have to do is we have to pass in another field in our service config so that it knows to pull the environment variables from that specific file. So what we can do here is in this file, we're going to go and just add another line. It doesn't matter where you add the line, but we want to say environment file, make sure to capitalize the E and the F, equals, and then you provide the path to your specific env file. So mine's going to be home/sanjeev.env. And I'll just copy all of this again. And we'll go back into etc systemd system. And then I'll just do a sudo vi api.service. And we're going to replace this file now. All right, so now we should be able to import all of those environment variables. And there's other ways to do this. You can also set up a config file for your new service. However, I figured it's just easier because we already have our environment, our .env file, so we can just continue to use that. And now if I do a systemctl restart API, and notice you don't have to type in api.service. It's optional. You can technically do it like this. And it looks like since we actually changed the file, we have to run this command now. All right, and so now let's do a systemctl restart. Sorry, not restart, status API. And looks like we got the same exact error. Let's just do a restart one more time. And we'll do a status. And now it's up and running. Perfect. Look at that. So we've got our 4 workers. These are the process IDs. And let's just double check and make sure that we can access our specific website. So I'm going to just refresh on the /docs. And it looks like it works. Let's go to the root. And let's go to the root URL. So I'll just change this to the root URL and see if we get the API response. Perfect. So it looks like we've got our application up and running. There's just one last thing we need to do. And I wasn't sure if I had already covered this, but there's one last thing I want to do, and that is I want to make sure that our service automatically starts upon a reboot. So that way, in case our machine goes down, whether it's because of a power failure or something like that, or maybe we perform some sort of upgrade, I wanted to automatically start this service so that our application is always up and running. If you do a systemctl status API, you could find out pretty easily whether this service is going to get started upon a reboot. So if you take a look right here under loaded, and then right here is the keyword that you're looking for. If you see disabled right here, that means that it's not going to automatically get started upon a reboot. If you see it's enabled, that means it will automatically get started upon a reboot. So to actually make sure that it actually does get started upon a reboot, just do a sudo systemctl enable, and then the name of the service, which is API. And after that, if we do a status again, we should see that it moved to enabled. And so now if we reboot our machine, and you guys can go ahead and test this, you'll see that it automatically starts up the service. Right now, the way that we have our deployment set up is that when we send a request to our server, to the specific IP address of our server and whatever port we decided to configure our app to listen on, we send that request directly to the app or gUnicorn in general. And this is technically perfectly fine. However, you'll see that in more professional type deployments, what we'll have is a intermediary web server. So we'll have a web server running on our Ubuntu machine, and that web server will receive the original request and then act as a proxy and proxy that request to our specific application, or gUnicorn in this case. And so one of the common web servers that can be used for that is Nginx. There's a couple others like Traffic and HAProxy. You'll see that Nginx is fairly popular though. And some of the benefits of doing this or in configuring our application ultimately to be deployed like this is that Nginx is optimized for SSL termination. So Nginx is a high performance server, and it can perform all of the SSL termination. So when we send an HTTPS request, we can send it to our Nginx server. The Nginx server can process it and then forward it as a plain HTTP packet to our application. Because technically we could configure our application to handle HTTPS, it's not optimized for that, right? Our app is designed to just act as a plain API. When we start adding responsibilities like performing SSL offload, well, then you'll see that we start to see a degradation in performance. And Nginx, like I said, is a high performance web server. It's optimized for this, so it makes sense to kind of handle that responsibility on Nginx instead of our application. So that's what we're going to do. We're going to configure Nginx, and this is going to act as the gateway into our system. So any request we send to our system, whether it's HTTPS or HTTP, it doesn't really matter. We're going to send it to Nginx. And if we send it as HTTPS, what Nginx will do is it'll then take it and send it and forward it as an HTTP packet to our application. And so I'm going to walk you through how to set up Nginx. It's not difficult. We do have one config file that we have to add, but outside of that, it's fairly easy to get this up and running. Let's install Nginx now. To install a package, we can do sudo apt install and then Nginx and then -y. So that installed Nginx. If we do a systemctl start Nginx, that's going to start up the Nginx service. And so now if you go to your server IP address, you're going to see that you get this welcome message. So this is just the default page that Nginx loads up for you. And we're going to change this. So in Nginx, what we want to do is we want to go to /etc Nginx sites and then available. It's important that you do available because there's also a sites enabled, which is not what you want. You want available. And there's this default config file, or technically this is a server block. And if we take a look at this, you can see the default configuration in this case. Just to show you what that looks like, you can see that this is handling HTTP traffic. That's why it's port 80. It's going to listen on port 80. And this is going to act as the default server. So all requests that come here are going to land on this server block. And we've got the same thing for IPv6 as well. And then this is the file that you actually see. So when you navigate to this page, it's actually loading up a file that's in /var/www/html. And then the server name. So this is going to be the actual domain names it's going to handle requests for. This is basically saying everything. Everything else, don't worry too much about that. But what we're going to do is we're going to change that file a little bit. And I've provided an example file here. And so this is what the example file looks like. We can leave pretty much everything in place. The only thing I want to change is this location block. And so this is what is going to allow Nginx to act as a proxy, specifically this line. This is the main line. You don't technically need the other ones. Those are more of optimizations. But all this is saying is that any requests that match the root path or beyond, essentially, is going to get proxied to localhost port 8000, which is what gUnicorn is running on. So you just specify the IP address and the port that you want to proxy traffic for. And so since gUnicorn was configured to run on port 8000, we're just going to forward it to gUnicorn in this case. So I want you to just copy these lines here, and we're going to go in, and I'm going to just open up that default file now. And we can delete these 3 lines. I'm just going to paste that in. And at that point, I can save this. And then we want to do a systemctl restart nginx. So it's restarted. And if I refresh this, right, we can now see our API. And if I go to /docs, it should also work as well. So we got nginx set up and running. The last thing that we have to do regarding nginx specifically, well, it's not really nginx specific, but in general, is that right now, if you take a look at it, you can see our web browser says not secure. And that's because I can actually copy this. If I paste it, right, we're using HTTP and not HTTPS. So we need to set this up for HTTPS. So how do we do that? Well, we're going to tackle that in the next video. But you're going to need a domain name if you want this to work with HTTPS. So I'll show you guys how to kind of grab a cheap domain name. However, if you don't have one, don't worry. You could just leave it as HTTPS for now, or you can create a self-signed certificate, whichever one works for you. For my application, I purchased a domain name called sanjeev.xyz. So if you've ever watched any of my other videos, this is always the default domain name that I use for demonstration purposes. You can see that I actually bought a .xyz because they're the cheapest. So if you just want to play around just for learning purposes, get a .xyz. They're usually like $1 for like an entire year. But if you get a .com, it's going to be a little bit more expensive. However, depending on what your domain name is, it at most is still, well, not at most, but you can still find plenty at $12 per year. So it's not too bad. And I happened to purchase my domain name from Namescheap. So this is my domain registrar. However, there's plenty of other options. If you want to use GoDaddy, if you want to use any of the other websites, you can even use Amazon if you wanted to. Feel free to use whichever one you want. You just need to get a domain name. I'm going to be using this one moving forward. So just keep that in mind. And what we want to do is we want to set up a couple of rules. And we actually have to point our domain name to DigitalOcean. And DigitalOcean has this excellent write-up, how to point your DigitalOcean name servers from common domain registrars. And they actually show you how to do this for a lot of the main domain registrars. And they have Namescheap here as well. So if you get one of these, you can just follow along. But you'll see that any domain provider, you'll be able to kind of relatively click around and just kind of navigate yourself and figure out what's the equivalent. Because for the most part, the UIs are all fairly similar. But if we go down to Namescheap, you can see that what we have to do is under the name server section, we have to do custom DNS. And then we point it to the DNS servers of DigitalOcean. So ns1.digitalocean.com, ns2, ns3. So let's do that. And I've actually already set that up for us. So you just go under name servers, select custom DNS, and then you have ns1.digitalocean.com, ns2.digitalocean.com, and ns3.digitalocean.com. And there'll be a little check mark, so just check that there. And at that point, it's going to point everything to our DigitalOcean servers. Then in DigitalOcean, if you just select your name here in your dashboard, what you want to do is you want to go to manage DNS on DigitalOcean. And then here you want to enter your domain. So this is going to be sanjeev.xyz. We'll add this domain. And the first thing that we have to do is we have to create an A record. So this is the root of your domain. So I'm just going to say @symbol. This is going to create an A record. And we want to select the specific droplet that we created. So this one's Ubuntu Fast API. You should only have one. But if you have other droplets, make sure you select the right one. And then select create record. And at this point, if we do sanjeev.xyz in our web browser, it's going to take us to our DigitalOcean server. However, keep in mind, the changes to DNS usually take a little while to propagate. So you could potentially have to wait up to an hour or 2 hours. Namescheap says it could take up to a day, but it never takes a day. So if you don't see these changes immediately, just give it 10, 15 minutes, and then you'll see that they work. But I'm going to add one more, and that's going to be for my subdomain, because I don't want to just do sanjeev.xyz. I also want to redirect www.sanjeev.xyz to my server. So I can create a CNAME record. And I can say www. And so you can see what this is going to look like. And I'm just going to say @symbol right here. So that's going to point it to this record essentially. All right. And so what this is saying is that if you send a request to sanjeev.xyz, it's going to send it to the IP address of our server. And then if you send a request to the subdomain of www.sanjeev.xyz, it's going to be an alias for sanjeev.xyz. So it's essentially just going to follow this. All right. And so now if I go to sanjeev.xyz, you can see that we are successfully able to access our API. And if I go to /docs, once again, this should still work as well. And that's pretty big. Let me minimize that. And if I do the same thing for my subdomain of www.sanjeev.xyz, this should also work. All right, so we've got our domain set up. And once we have our domain, we can now finally set up SSL. So we can handle secure HTTPS traffic because we don't want to send our application traffic over HTTP. And we want that nice little lock symbol, that green lock symbol. So we'll tackle that in the next video. Okay, so it's now time to set up SSL for our application. So I want you to search for certbot. So this is the website for Let's Encrypt, which is a free SSL service. And here they've got excellent documentation. What we want to do is select get certbot instructions, and then we can just specify what software we're running. So this is for Nginx, and the system is going to be Ubuntu 20.0.4. The reason it asks for this information is that it actually will automatically reconfigure Nginx for you to handle HTTPS because normally when you want to set up HTTPS, you have to change some configs in Nginx, and it gets a little complicated. And so it's saying the first thing that we have to do is we have to install Snapd. If you installed Ubuntu, from DigitalOcean, Snapd should automatically be installed for you. So you can do snapd -- version, I think. Or is it snap -- version? I think it's snap version. Yeah. Okay. So it's snap. Okay. So we've got snap installed. That's perfect. And then what we want to do is we want to install with this command right here. So just copy this. And we're pretty much just going to follow this website because like I said, the instructions are fantastic. So we'll install certbot. All right, certbot's installed. Then we want to do this command. So you have two options. You can either just generate a certificate, or you can have certbot automatically configure Nginx for you. We're going to have certbot do the work for us. And so we can just paste this in. All right, and then we have to provide an email address. So this is going to be whatever email you want to use. And then we got to agree to the terms of service. You can do no for this one. Right, then we have to specify what domain names we want to generate a certificate for. So we want to generate a certificate for sanjeev.xyz in my case, and then www.sanjeev.xyz. All right, and it looks like it did some magic to our default config file that we were originally changing. So if we actually go to the sites available folder, which we're already at, and just do a cat default, you're going to notice some changes to this file. And that's because certbot actually made a whole bunch of changes. And the main change is, where are these changes? Not here. Here we go. So this server block is for SSL configuration. And so these are the changes they made. So we're going to listen on port 443. So that's the default SSL or HTTPS port. That's good. And I guess that's for IPv6. This is for IPv4. These are going to be the two certificates that were generated. And then there's a few other configs that it added. And we also have this server block right here, which is going to actually redirect HTTP requests to HTTPS. So we can never even use HTTP anymore. It's going to ensure that our clients always use HTTPS, and it'll redirect them to HTTPS. And if you can see that right here, if host equals www.sanjeev.xyz, we want to send a 301 redirect to HTTPS and then host request right here. And we're doing the same thing for just the sanjeev.xyz. And so that's all done by certbot. And so now if I go here and I do sanjeev.xyz, take a look at this. We got the little green lock. That means connection secure. That means we're using HTTPS, and you can see the HTTPS here. And if I hard code it to be HTTP, look at that. It still has the lock because it redirected to HTTPS. And let's just make sure that the docs work now. And it looks like the docs still work. So we now have HTTPS set up on our Nginx server. And just like we did with our service, we want to make sure that Nginx has been set up to automatically start upon a reboot. So we could do a systemctl status Nginx, and let's just quickly verify if it has been set up to do so. And I can see that on mine it's set up to be enabled, so it will automatically start upon reboot, which is what we want. And I think this is the default configuration when you install and set up Nginx. However, if you see disabled here, just go ahead and do a systemctl enable Nginx, and that's going to make sure that it will be moved to an enabled state so it'll get started upon a reboot. The last thing that we need to do to complete our deployment process is set up a firewall on our machine. And the reason we want to set up a firewall is just for basic security purposes. We want to make sure that we only open up ports that we're going to be using. Because right now you can access this box on any port, and we want to make sure that we really harden our system so that only the traffic that should be sent to this box is allowed to this box. We don't want people trying to connect to different services on our machine that they shouldn't be. So we're going to be using the built-in firewall called a UFW. And if we do a sudo UFW status, right, the UFW is the firewall. And so you can see right now it's inactive, and that's perfect. And what we have to do is we have to set up a whole bunch of rules. And we have to tell the firewall what kind of traffic should we allow to our machine. And we can run sudo UFW allow, and then we can specify what specific port we want to allow traffic on, what specific IP addresses we should be able to talk to. So since this is a public API, we want to make sure that technically anyone can access our server from HTTP and HTTPS. So we're going to do allow HTTP. So this is going to allow HTTP traffic. And you can see it created an IPv4 and an IPv6 rule. We want to allow HTTPS traffic. And keep in mind, we have to SSH to our machine so we can access it. So we have to allow SSH as well. And if you wanted to, you could also allow 5432. So that's going to be to allow Postgres traffic. Now, the way we've set things up, you don't need to actually allow this port because technically our app, right, our fast API is running on the local machine. So it's not going to be hindered by this firewall. So it can access the database because it's running on the local machine. So if you wanted to make it so that no one from the outside world can directly access your database, you would not want to allow this. And that's what a lot of people do because it can be a little risky opening up your database port because then people can potentially access your database. So it's up to you. However, if you want to be able to, go to pgadmin, and if you want to be able to connect to your box remotely, then you're going to have to allow 5432. So it's just up to you. It's your preference. Do whatever you want to do. I'm going to allow this just for demonstration purposes so that I can show you that, hey, when you allow 5432, we can connect remotely. So I'll add that rule. And then finally, we have to start our firewall. So we do sudo UFW enable. And it's just going to tell us that we could potentially lose connection because we're starting up a firewall. That's fine. And we've started up a firewall. So if I do a sudo UFW status, you can see that it's active and you can see all the rules that it's put in place. So it's saying we allow port 80 traffic from anywhere. We're going to allow that. Port 443, we're going to allow from anywhere. And same thing with SSH and 5432 and all of the IPv6 rules as well. And then everything else is dropped and blocked. And let's just double check that we can access the docs. And it looks like we can. And just to make sure it's not cached or something like that. Still works. And now we've got our firewall. And the firewall will start up automatically, so you don't actually have to configure anything else. If you do want to delete a rule, you can do sudo UFW delete allow, and then whatever rule. So you can do HTTP or you can do 5432, whichever one you want to delete. So now that we have our application deployed, one of the common things that you're going to have to do is make changes to your application and then push out those changes. So I'm going to show you guys how we can do this in a manual process. Ultimately, if you're developing an application, it's best to set up a very efficient CI/CD pipeline, but that's a little outside of the scope of this course. So I'm going to just show you how to do this manually, and you'll see that it only requires a couple of commands. So go ahead and make your changes, whatever code changes. So I'm going to say, hello world, couple of exclamation points. All right, we'll save that. And what we're going to do is we're going to do a git add -- all again. And we're going to do a git commit -m, give it some meaningful message. changed the world. All right, and then we're going to do a git push. And before we do that, if you type in, just do a git push. Then we provide origin, which is the name of our remote, and then the branch that we're on. So we can say main. And that's going to push it up to our GitHub repository. And at that point, once it's there, you can just quickly verify if you want, but I'm going to assume that it's there. And then what we're going to do is we're going to go into our application folder, which is in our home directory. Then we go into apps and then source. And then here, we're just going to do a git pull. So it's going to pull all the changes that were made. So it's going to grab the latest changes and we'll... All right, so we've pulled all of our code now. And keep in mind, if you had changed the requirements.txt file, then you definitely want to do a pip install, pip install -r requirements.txt if you did, but we didn't change any of that, so we don't need to do that. And what we can do now is we have to restart our application, because if I just refresh this, you can see nothing's changed. There's no exclamation points. So we'll do a sudo systemctl restart API. And let's try this out now. And we've got all of the exclamation points now. So that's how you push out changes through a manual process. But like I said, it's best to set up a CI/CD pipeline. In this section, we're going to focus on Dockerizing our application. I originally wasn't going to do anything on Docker, but I figured I would just make a quick video just to show you guys how we can quickly set up our fast API environment within a Docker-based environment. And I'll also show you guys how to set up a Postgres database within Docker. This is going to be a fairly quick run through of Docker. I'm going to assume that you guys have a basic understanding of Docker. I'm going to assume that you already have Docker installed on your machine. So we're going to get right to it and get started on setting up our fast API within Docker. So I have Docker Hub open, which is just, a public repository of different images that we have access to. You can create an account if you want to. You don't have to create one at this stage. The only time we'll need to create an account for this course is if you want to push an image up to a repository hosted on Docker Hub. If you don't want to do that, then you don't need to go ahead and create an account. But what we want to do is we want to figure out an image that we're going to use for our fast API, a Docker container. And so just go ahead and search for Python. And what we're going to do is we're going to use the official Python image. So select the official Python image, and you'll see that there's a couple of different options. So you can scroll down, you can see the different versions of Python. And we're actually going to use version 3.9.7 in this case. But you could see that with the default Python image, we have all of the different versions that we could pretty much ever want. And then they got Slim images, they got the Alpine images as well. But we're going to use just the standard image. Now, if we use this specific image, the problem with this is that this is just a basic image with Python. There's nothing else on it. And at that point, if we just have a basic Python container, then we have to do all of the work of copying our source code onto the Docker container, and then we have to install all of our dependencies and set up our application. And that kind of defeats the purpose of Docker, because the main idea behind Docker is that we actually create an image that has everything that we need to run our application. So we just start up the image, or I guess we technically start up the container, which is made from the image, and that should just have everything it needs, and it should just start working right away. So that's exactly what I want to do. And to actually get that to accomplished, we're going to have to create our own custom image. And all custom images need to start off with the base image. So we're going to start off with this base Python image, and we're going to customize it by doing a few things, including copying our source code into it and installing all the dependencies and setting up a few other details. So to actually create a custom Docker image, we're going to go to our project directory, and we're going to create a file that's referred to as a Docker file. Now, this Docker file is going to have all of the steps necessary to create our own custom image. And the first thing that we have to do is we have to set up or specify our base image. So we're going to use this Python 3.9.7 image as the base image. So what we do is we say from, and then the name of the image. So this is the Python image. And then if we want to, we can also do a version. So I'm going to do 3.9.7. And if you're wondering where I'm getting this from, this is all from the documentation. You just say from, the name of the image, which in this case is Python, And then you could see the different tags. So if you want 3.9.7 slim bullseye, that you got that. And if you want to see them going over that in an example, we're kind of basically just following this essentially. The next step is going to be an optional step, but I always like to do this. We're going to use the workdir flag, and this is going to set the working directory. So I'm going to say this is going to be user source /app. Now, how do I know that there's a folder called user/source? I've actually run the Python image myself, and I checked to see where I could actually set up my application. So I found that there is a path here, and then I want to create a folder called app, and this is where I'm going to store all of my application code. And once again, you can take a look at the documentation, and it does the same thing. So if you're ever lost, just take a look at the doc, and it's going to help explain things. But like I said, this is the optional command in this case, because what it really does is it's going to tell Docker, this is where all of the commands are going to essentially run from. So it's like doing a CD into /user/source/app, and then anytime we give it any instructions, it's always going to do everything in that directory. So it's just going to help simplify some of the later steps, but it is technically optional. The next thing that I want to do is I want to copy our requirements.txt file from our local machine onto our Docker container. So we use the copy command, and we see we want to copy requirements.txt, and then we have to specify the directory within our container or image that we want to copy it to. So I'm going to say /. So where does this exactly point to? Well, remember, we set our working directory. So everything is going to be with regards to that directory. So when I say the current directory, that means this directory. Now, if we didn't have this line right here, then we would have to specify the full path to that directory. So you can see that it's kind of simplifying things for us, because then we can just kind of say, hey, I want to use the current directory because that's what the working directory is. And the next thing that I want to do is run a command, which is going to be responsible for installing all of our dependencies, because we have our requirements.txt file copied into our Docker container. So we're going to do pip install -r and then requirements.txt. And if you want to, we could also specify the --no -cache -dir if you wanted to as well. And so that's going to install all of our dependencies. Then the next thing that I'm going to do is I'm going to do copy ... So what does this mean? This is going to copy everything in our current directory, so all of our source code, and then it's going to copy it into the current directory in our container. So what is the current directory? Well, that's the one that's set by workdir. And once again, if we don't have this defined, then we would have to specify the full path of /user/source/app. Now, one thing that you might notice that's a little unusual is the fact that we copy all of our source code at the end right here, which is going to include everything in our directory, including the requirements.txt file. So you might be wondering, well, why exactly do we copy just the requirements.txt file up here? Well, this is a little bit of an optimization that Docker provides us. So when Docker runs, when we build images from a Docker file, it actually treats each one of these lines or steps as a layer of the image. So kind of builds an image by running the first layer, then creating the second layer, the third, fourth, and fifth layer. And it actually caches the result of each step. So this is important because when you cache the result, if nothing changes, then we can just use the cache result. So let's say I, run this image, or I create an image from this file. It's going to take a certain amount of time because it has to do a pip install requirements.txt, where it's installing all of the dependencies, which does take a decent amount of time. But if I run this again, right, and nothing changes, well, then it can just use the cache result because it knows nothing's changed. And this is important because when I change my source code here, maybe like my database.py file, it's going to see what steps changed, right? And so if I change my source code, does that change the base image? No, we're still using the same base image. Does it change the working directory that we used? Nope, still the same. Did it change the requirements.txt file? Nope, still the same. Did it change any of the dependencies that we installed? Absolutely not. It only changed the final step. So this causes Docker to be able to use the cached result of step 1, 2, 3, 4 of step 4, and it only has to rerun step 5. But if we change requirements.txt, this file right here, then it knows that this step changed here. So it's going to have to rerun this step, then this step, then this step. Right? And so this gives us an advantage because anytime we change our source code, we only have to run this last step. And if we change our requirements.txt, then we have to run all of these steps. And keep in mind that this step is the longest step. And so if I had actually, if I can comment this out. So if I didn't have this line and instead I copied all of my source code right here, what would happen is every time I changed any code in any of my files, I would have to rerun a pip install every single time. And that would cause us to have to rerun the longest step in our build process. And so that's why we have this optimization. That's why we copy the requirements.txt file so that we can cache that result. And so anytime we make any changes to that file, anytime we make any changes to our source code that's not in that file, we don't have to rerun a pip install. All right, and then finally, we have to give it the command that we want to run when we start the container. So we'll say cmd brackets. And so the command that we want to run is uvcorn app.main app. And so the way we actually specify the command is we break out each word of the command. So here we do uvcorn, and then we say app.main app. And then here we're going to pass in the host flag and the port flag like we did on our Ubuntu machine. So we do --host 000, and then we do --port. That's going to be 8,000. Okay, so it's basically anytime you have a space between the commands, you just split it up into a different string within this list. That's just kind of the syntax that you have to use with these Docker files. But it's the same thing as running uvcorn app.main app and then --host --port 8,000. Oops, 8,000. So it's just going to essentially run this in our container. We just have to provide it in this format. All right, and so now our Docker file is complete and we can actually build our image. So what we're going to do is I'm going to do a Docker, and then the command to build our image is build, and then we'll do a --help so we can see all of the different flags. And most of these don't really matter. The only one I really care about is a tag. So I want to give this a name. So I'm going to say Docker build -t. I'm going to give this image a name that I think is reasonable. I'm just going to call this fast API. And we have to pass in one last argument, which I forgot, which is going to be the context. You could think of the context as just kind of the directory where the Docker file is. So it's going to be in the current directory because we can see the Docker file is in the root of our folder structure. So I could just say dot. And so now it's actually going to build our image. And if I do a Docker image ls, we can see all of our Docker images, and you'll see that I've got a whole bunch, but we've got my fast API right up here. And so now we can go ahead and use this image for actually building out a container. And we can run a whole bunch of Docker commands like docker run, and then specify the image that you want to use, and then pass in all the flags. But I don't like doing that. I don't like working with Docker run. Instead, I want to use Docker compose. And if you have never worked with Docker compose it does the same thing as running Docker commands on the CLI. We just provide all the instructions on a file so that we don't have to remember all of these long commands with all of these extra flags. We literally write out the flags in a file, and then we can just say Docker compose up, and it's going to bring up all of our containers. So we're going to take a look at Docker compose in the next video and see how we can get that set up. All right, so we're going to learn about how we can use Docker compose to automatically spin up our containers with the desired configuration. And you're going to see that it's so much easier to use Docker compose than just running docker run whenever you need to, because we can spin up multiple containers all with one command, and we can also tear them down all with one command. And to use Docker compose, we have to provide the set of instructions using a file called docker-compose.yml. And so this is a YAML file. And if you don't know too much about YAML, it's just I guess it's technically like a markup language, I guess. But the most important thing to understand is that spacing matters. So this is kind of like Python, where you need to make sure that the tabs and the spaces are just right and everything lines up, or then it's going to start to throw errors. And the first thing that we need to do is specify what version of Docker Compose we want to use. So we say version, and I'm going to say just version 3. It's not the latest, it's just kind of the most common one. If you actually go to the Docker documentation for Compose file, you'll see the different versions that you can specify, and you can actually take a look at the documentation and see what feature was introduced in what version, so you can figure out what version you need to perform all of your operations. We're not doing anything special, so version 3 is just fine for us. Then within Docker Compose, we have a concept of services. And so a service, really, at the heart of it, is nothing more than just a container. So if you want Docker Compose to spin you up a container, you have to define a service. If you want Docker Compose to spin up 4 containers, we're going to have 4 different services. Pretty simple. So we have to give each service or each container a name. So we're going to have one container for our fast API. And I'm just going to call this container API, or this service API. And the first thing that we need to do is we have to specify either the image that we use. So I could technically say like image, and then we can point to like the Python image, or I can specify build, where we can essentially do the same thing that we did before in the previous video, where we ran docker build and then provided the location of the Docker file. But we could just specify that here within Docker Compose, so that Docker Compose will automatically build the image for us if it doesn't exist. So we'll say docker build, and then we specify the context or the path to the Docker file, which is the current directory, based off of where the Docker Compose is. So they're in the same directory. So I just say current directory. And then we have to specify a port that we want to open up, because this is an API. So the outside world needs to be able to reach our container. But by default, all containers can't talk to by default, the outside world can't actually talk to your container. So we have to open up or poke holes on our local machine to open up some ports. So we say ports, and this expects an array of ports. And so there's 2 different ways to do an array. With YAML or with a Docker Compose file, we can do, just an array like this, where we just provide a list of things. Or we can also do it like this, where we do a dash and then provide, something, and then a dash for the next entry in the list. So I'm going to use this syntax because I kind of like it better. But to open a port, there's a specific format that we're going to use. So what we say is there's going to be 2 numbers. There's going to be the port on local host, and then we do that, and then we do the port on container. All right, so what's essentially happening is we're telling Docker, if we receive traffic on our local host on this port specified here, we're going to forward it to this specific port on the container. So the second number is a little bit easier to set up, because it's going to be whatever port our application's running on. So if we take a look at our Docker file, we can see that our container is going to be listening on port 8000. So we want to set this second number to be port 8000. And keep in mind, you could choose to use any other value. So if you decided to use port 80 here, then you would just change it to port 80 here. But I'm going to leave it as 8000 just for simplicity's sake. Then the second number that we're going to use is going to be the port on the local machine, or on the local host, which in this case is my Windows machine. But if it's on like a production server, it's going to be whatever machine or IP of that specific server is. And so here we could specify any port. So you can literally pick any port that's open. So if I said port 4000, what that means is that, if I go to my my Postman, this would be the equivalent of doing localhost colon 4000, right? Which is that first number. And so anytime we send traffic to that specific port on a local machine, it's going to route it to port 8000 in our container, which is what port our application's listening on. But if I change this to port 8000 as well, then our request would be localhost port 8000. So I always like to have the 2 numbers match up because it's just simpler, but sometimes that's not an option. So just pick a open port on your localhost machine. It doesn't really matter what it is. Just make sure that you remember what it is. And I'm going to leave it like that, and I'll delete this line right here. And for now, I think this is good enough. And what we're going to do is we're going to try to run this and see what happens. So I'll say docker-compose up. And then if I do a -- help, we can see some other flags that we may need. And the only flag that I really need right now is the -d. So this is going to run the containers in the background so that we're not automatically connected to it. So I'll do just -d. right? And so you'll see if you take a look, what's happening is we're rebuilding our image. So because we specified the build right here, it's going to build our image, and then it's going to start our containers. So you can see that it's creating fast API underscore API underscore 1. And so the naming syntax comes from the project directory. So it's called fast API, right? So that's why the first word. Then we do underscore, then the name of the service. So I called this service API, so then it's API. And then it has the number 1 because there's one instance, but if I told it to spin up 4, then I'd have 1, 2, 3, and 4. So we've got our container. If I do a Docker PS, we should be able to see. Nope. Oh, we can see it's down, and that's because if I do a Docker PS-A, and we can see that this one right here looks like it stopped 43 seconds ago. And so it crashed for whatever reason, and that's okay. What we can do is, I think we can actually see the logs after it goes down. So if I do Docker logs fast API 1, we can actually take a look at the logs at what caused it to go down. And we can see a couple things, but we can see that we get the Pydantic error for our settings object, which is all of our environment variables. So obviously a container is like its own separate machine. So it needs all of the environment variables passed to it, or then our application is going to crash. So how do we pass an environment variable in Docker? Pretty simple. We just pass a environment field. And then here it's going to provide, you need to provide an array of environment variables. So I do dash. And then here we just specify our environment variable. So I'm actually going to copy and paste this section right here. And so these are all of our environment variables. Keep in mind, if you don't want to actually write out all of your environment variables, we can actually use Docker to point to a .env file or a environment file on your local machine. And if you want to do that, it's pretty simple. Here we would just specify the env underscore file. And then you can actually provide multiple files, but in this case, you just provide the path to the file. So it's going to be in the current directory, and it's going to be .env. So you can do either one or a combination of both. I'm just going to use this format so that we can see all of the environment variables, and I'm going to just comment this out for now, just for documentation purposes. And now what we're going to do is we're going to do a Docker compose down just to tear everything down. And I'm going to bring it back up in detached. And notice this time it didn't build the image. So why exactly didn't it build the image? Well, Docker Compose is very simple. All it does is it goes to Docker image, basically just runs a Docker image ls, and it looks for the image that it would have created. And there's a very specific format that it uses, which is going to be the name of the folder or the directory, and then underscore, and then the service. So since the image was already created previously, it doesn't recreate it. However, if you obviously make changes to your Docker file and you want to make changes, then you would have to do Docker up. And then if you look for the flags, there should be a let's see, build. This is going to force it to build a new image. So keep in mind, anytime the image has to change, and but the image already exists, then you have to pass in that flag to force Docker Compose to let it know that, hey, I made some changes. I need you to rebuild it for me, because Docker Compose can't detect that. All right, so now if we do a Docker PS, we can see that it's running now and it didn't crash. And we should be able to access it on port 8000. So if I actually go here and just do localhost 8000 with the GET request, looks like it's working. Okay, so now that we can actually access our API, which is running in a container, the next thing that I want to do is I want to set up our Postgres database. And you might be thinking, well, we already have one installed on our local machine. Why are we setting up another one? Well, a couple things. First of all, if we're already Dockerizing our environment, it makes sense to set up our Postgres database, especially from a development perspective within a Docker container, because it's so much easier to set up a database in a container than it is to install it on our local machine, because we just spin up a pre-built image and that's it. So even if you don't actually want to Dockerize your application, from a development perspective, I strongly recommend you make use of Docker containers so that you can spin up a quick database just for testing purposes. But since we already have a Docker-based application now, we're going to just use a Postgres database that's running in a Docker container instead of on our local machine. Because if we take a look at the environment variables that we pass to our container, we provide a value of localhost. And so localhost means that the container is going to, or the API running in the container is going to try to access a database running locally on that container, which it's not. So let's create a brand new service, which once again is nothing more than another container for running our Postgres database. And so I'm going to go down here and we're going to create another service called Postgres. And here we're going to provide a image flag, right? Because here we did build because we're building a custom image. Here we're going to use the pre-built default Postgres image. So if we go back to Docker Hub and search for Postgres, you'll see this is the official Postgres image. And this is going to contain all of the documentation for setting up Postgres. But the main thing is there's a couple of environment variables that we have to pass. So first of all, the password that's going to be used for our database. We can give an optional Postgres user, but it's going to default to Postgres if we don't provide it. And then we also want to give it a Postgres database name. So we'll call it Fast API like we've been using in our development environment. And that should be all that we have to do for the most part. So here I'll say environment. And we'll do Postgres _ password equals, and then we can give this anything we want. So password 123. And then we want Postgres _ DB. So this is going to be Fast API. All right, the next thing that we want to do is when it comes to data within a container, that data doesn't persist as soon as the container goes down. Right? So when you delete the container, you lose all of your data. All right? And so from a database perspective, we don't actually want to lose our data. We want that to persist even if we kill off the container. So how do we actually save that data? We have to create something that's called a volume. And that's what allows us to save data from a container onto our local machine, so that if we kill the container, we can always spin up a new container and just point it to those files. And there's a couple of different volumes that we can use, or types of volumes in Docker. There's anonymous volumes, named volumes, and I think bind mounts is the other one. We're going to make use of named volumes. And so to create a named volume, here under the Postgres database section or service, we're going to say volumes. And then we say dash, and then provide a name for the volume. So you call it whatever you want. I'm going to call this Postgres-DB. Right? And then we have to specify the path in the container that we want to actually save. So what directory do we want to persist on our local machine? And the path that the Postgres container or image actually stores all of its data, we can actually take a look at the documentation to figure this out. So if you search for volume, and so right here, this gives us an example, and this is going to tell us what we need to know. So we want to save /var/lib PostgreSQL/data. So that's where it's going to save all that data. So we'll copy that. And once again, this is the path in the container that Postgres is going to write to. So that's where all of our tables, all of the entries are going to get stored. So we want to copy that essentially and save it on our local machine. And the last thing that we want to do is anytime you use named volumes, we have to create another volume section globally and then just pass the name that we created. So whatever is here, you just put it down here. And the reason we have to do this is because named volumes are designed so that technically multiple containers can access them. So you define it down here first technically, and then multiple containers can reference them by just calling that. All right, so we've got this set up, and actually I realized I left my containers running. So what I'm going to do is I'm going to comment this out for a second, save this, and I'm going to do a Docker compose down. So it's going to delete everything. Then we'll uncomment our Postgres service. Then the next thing that we want to do is we have to figure out, what is the host name, or what's the IP address of our Postgres database. And, there's a couple of different ways to do that. But what's awesome about Docker is when you use Docker Compose, it creates a custom network. And a Docker network uses DNS. So we can actually say to reach the Postgres database, instead of looking for the IP address of that container, we can use DNS, and I can just say, if I try to reach the name Postgres, right, it's automatically going to resolve to our Postgres service. So whatever our service is called, we can just reference that. And this is going to allow this container to know that when you want to talk to the Postgres database, this name here is going to resolve to the IP address of this container. And so networking with Docker within Docker is so simple because that's all we have to do. And then the rest of the things, the default port, the password, the database name, the database username, those should all be okay, and we can just leave as default. And now I can then start this up. And it looks like image, something's wrong with the image. I forgot to give the image. So what's the image name? It's just Postgres. So that's just whatever this name is. That's all you need. All right. And so now we can see that it started up both. Let's just quickly test our API so we didn't break anything. So that works. And then let's go to create user, make sure it's point to port 8000 in this case. And if we create user, right, you can see that we have successfully created the user. So it looks like we can now access the database from our Fast API container. Now, what I'm going to do now is delete everything again. So Docker Compose down deletes everything. And you can see I'm essentially able to destroy both of my containers with a single command. And that's kind of the power behind Docker Compose. And ideally, we want our Postgres container to start up first because our API is dependent on the container. So for our API, we can pass in another option. And I can say depends on. And here we can specify a list of services, in this case, just Postgres. And so this is going to tell Docker, I want you to start the Postgres container before the API container starts. Now, technically, it's not going to wait for Postgres to actually fully initialize. It'll just start the container. So you still want to put in checks in your code to make sure that, if you can't access the database because it's not initialized, you want to keep retrying. And so once again, we can bring this back up with a single command. And if you take a look at the order, you can see that we started up the database first. So now you'll always start up your database first and then start up Fast API. And then you'll stop Fast API first before stopping the database, because we set up the depends on. When it comes to working with Docker containers, we do experience a few extra challenges, especially from a development perspective. And I'm going to show you how those challenges actually work, or what those challenges actually are. And if I actually go back to my test request, wherever that is, where I'm just going to reach the default URL. So if I hit send, you can see it says hello world pushing out to Ubuntu, right? And that's because in my main.py file, it just says hello world pushing out to Ubuntu. Now, if I save this or change this and then save this, and then I send a request, right? We still get the same response. I don't get the new text that I added. So why is that? Well, there's a couple things that are happening, but the easiest way to figure this out is to actually poke around in your container and figure out what's happening. So I'm going to do Docker PS, and I want to see what the file system of Fast API container actually looks like. So to do that, we do Docker exec-it. So that's going to enter into interactive mode. We specify the container name, and then we type in the word bash. So what we're doing is we're entering interactive mode, and we're going to override the default command of the container. So the default command is specified right here from the Docker file. So we don't want to run that. We just want to run bash, which is going to allow us to access the file system. That's the image name. So the name of the container is fastapi_1. So let me add the 1. So now you can see that we get a Linux prompt. So we're in the Linux file system. And if I go into app and then go into, if I do cat, which is going to print out the contents of a file, we'll take a look at the main.py file. And you can see that it just says hello world pushing out to Ubuntu. So when I made these changes and added these extra characters, it didn't get pushed out to our container. And if you're trying to figure out why that is, it's pretty obvious, right? Because what we did was we created an image which copied all of our code here at that point in time. And then when we did a Docker Compose up, it created the image, and then that was it, right? Nothing else changes, right? Afterwards, we went in and changed the code, but the image was already created. So whatever's in the image, nothing changes after that point. So any changes we make will not get copied over to our container. So what do we do in this case? How do we get around this limitation? Well, what we can do is we can make use of a special volume called bind mount. And a bind mount is a special volume because it allows us to sync a folder on our local machine with a folder in our container. So this app folder, which has all of our application code, what we want to do is we want to sync this folder in our container with this folder here so that if any changes get made here, it's going to get copied over to our container. And so under volumes in our API, we're going to define a volume here. And I'll say volumes, right? Just like we did with Postgres, very similar, except we're going to use a different syntax because this is a bind mount. So a bind mount, we have to first provide the path of the folder that we want to sync on our local machine. So this is our current directory. So we can just do / for current directory. But if you wanted to sync just one individual folder, maybe like the app folder, then you can do /app. Up to you, but I'm going to sync everything. And then we have to specify the path in our Docker container, which is going to be this folder right here. And that's going to automatically sync the two folders. And if you wanted to add some extra security, you can do RO. This means read only. So what this does is this makes it so your container can't change any of these files, because only we should be changing the files, not the container itself. So this just adds a little bit of extra security if you wanted to, but it's still technically optional. And let me exit out of here. And now we'll do a docker-compose down. And we'll do a docker compose up again. And now let's just change this all together. So bind mount works. So if we see that, that means everything's working. So let's save it. And if I send, we can see that I get the old one now, right? So whatever I changed here doesn't get copied over. So it looks like we didn't fix the issue. So let's actually take a look and see what's happening. And so how do we do that? We'll do the docker exec command again to go into the file system. Let's go into the app folder and let's cat that main.py file. And this is interesting because it looks like the bind mount did work because we can see that the code got updated. And if I make another change again, this time let's just add sort of. And if I cat this again, we can see that it's in there. So the bind mount is working and it's syncing the code with our local directory and our container, but there's one issue. And if I go back to my Docker file, you can see that I have my command right here, but this doesn't have the -- reload flag, which is what we need to restart the application. So anytime we make changes to our code, we need it to automatically reload when it detects any changes so that we can actually see the new application. And we didn't provide that in the Docker file, and so that's why it's not working. So this is actually a pretty simple fix. We just add the -- reload flag. So let's tear everything down. And we have a couple of options. So I can go here and say -- reload, and that would work just fine. But instead of doing that, what I would rather do is, I like this default one because this is the one you would technically use in production because you don't want -- reload in production. But in our Docker compose file, we can actually overwrite it. So we can provide another flag called command. And here we can provide a command to overwrite that from the Docker file. So I'll say uvcorn app.main app -- host 000 -- port 8000 -- reload. All right, and let's bring this back up. Let's just see what it is currently right now. So we got whatever it is now, and let's make a quick change. And I'll just delete all of this and change this back to hello world. And let's test this out. And we can see that it does successfully update. And so now our bind mount works and we automatically restart our code. So our development environment more closely matches up with what we had before we moved to Docker. Okay, so if you haven't already done so, go ahead and create an account on Docker Hub. It's a free account, but I want to show you guys how we can set up a repository on Docker Hub so that we can actually store our images here. And so Docker Hub is kind of like the Docker equivalent of GitHub, where it's kind of acting as a repository, but instead of a repository for our code, it's a repository for our images. So we can upload our images. Anytime we make a new image, we can actually upload it so that we can track changes to our images over time. So make an account, and then we want to go into repositories, and we want to select create repository. and then give this a name. It doesn't really matter what you want to call it. I'm just going to call it Fast API. And then we're going to do public because you only get one private repository. And so now we have a private well, it's the public repository. And so this is the URL to the repository, which is going to be your username. This is my username. And then this is the name that I gave it, so Fast API. And so now what I want to do is I have an image, right? If I do Docker image ls, we could see that I have my Fast API underscore API. This is going to be the image that I want. And so how do I actually upload this image to Docker Hub? Well, there's a command called docker push. All right, so if I do a docker push --help, you just pass in docker push and then the name of the image. So let's try doing that. We'll do docker push and then the name of the image, which remember, yours is going to be a little bit different because it's going to be based off of your folder. Let's try this. And it says requested access to resource is denied. So the first thing that we have to do is we actually have to do a Docker login. So we have to log into our account. So you do Docker login here. It's going to ask for your credentials. So we'll do sloppy networks in this case for me, and then it's going to be whatever it is for you guys. And then now let's try to push it again. And once again, we get a access to resource is denied. So what exactly is happening here? Well, when we want to push up a image, right, there's a very specific naming convention that we have to use, right? We have to name it exactly like this, sloppy networks / fast API. And we even see an example right here. So you do docker push, the name of your email or your account name, then the name of the specific repository, and then you can give it an optional tag name. So what we got to do is we got to rename our image. So how do we do that? I think it's docker image. I think, well, let's do --help just to see if we can figure it out. We want tag. So this essentially copies an image and renames it for you. So let's do docker image tag --help. And here we just provide the source image and then the target image. So what is my image called again? It's going to be this one right here. And we just do docker image tag, then the image that we want to rename. And then we give it the new name, which has to be your account / then the repository. And then you have an optional, tag. The default is just going to be latest. So I'm just going to leave it without a tag. So I do that. And if I do a docker image ls, we should see the new one right here. And so now I can do a docker push. It looks like I didn't copy that. So let's try this one more time. And now it looks like it's pushing something. So let's give this a minute or two. And then once it's done, let's take a look to see if we have successfully pushed it to our repository. All right, so it looks like it's successfully pushed. So now if I go back to my Docker Hub page and do a refresh, we can see that last pushed was a few seconds ago. So now we've successfully pushed it to our Docker Hub. And so, if we set up an actual production Docker environment, we could just pull the image from this specific URL or this specific repository. Now, before we wrap up the Docker section of this course, there's one last thing that I want to show you guys. And that is that if you take a look at what we have right now, we have a identical clone of our previous development environment, but we're now developing within a Docker container. So our Docker container environment is a exact clone of our previous development environment. The issue is that, when we move to production, assuming that you're using Docker in production, which is kind of the main idea behind Docker, is that your development environment and your production environment are almost exactly the same because you're using the same exact Docker images and containers. But if we try to use this Docker compose file in production, there's going to be a whole bunch of issues. First of all, obviously these environment variables would need to change and we can't hard code them. We wouldn't want the -- reload flag. And you certainly don't want a bind mount because the code shouldn't be changing. And then the ports that we use could also potentially be different. So even though the Docker environments from our production and development environment should be roughly similar, there are going to be some differences. And so we need to account for that. And so what I like to do is I actually like to create two different Docker compose files, one for development and one for production. So that's what we're going to do. But first of all, let's do a docker compose dash down so that we can just tear everything down for a second. And once that's down, I'm going to copy this and paste it. And we're going to rename these files. So this one is going to be called docker compose dash dev. So this is going to represent our development environment. And this one is going to represent our prod environment. All right, so we've got our dev and our prod environment. The dev doesn't need to change because we had already set that up for a development environment. The production one is going to change a little bit. So first of all, the command, right? We don't want the dash dash reload. So we could specify the exact command we want, which is the one without the dash dash reload. And that should be all that we need. However, keep in mind, this is the default command from the Docker file, right? So we could technically just remove this or just comment it out. And so I'm just going to comment it out in this case. But if you wanted a specific custom command for production, you can just provide that here. The whole idea is that this file is going to represent all the changes for our production environment. Then maybe we want, instead of listening on port 8000, we want port 80 so that we can use our web browser. Most of the things can stay the same. The environment variables definitely need to change. And so with a production environment, first of all, we're not going to hard code the values. We usually want to grab these values from the environment variable set on the host machine. So instead of actually hard coding these in, instead we can reference environment variables. So to reference an environment variable, what we do is we do $ curly braces and then the name of the environment variable. So it's going to look on the Linux machine that it's running on for a environment variable called database hostname. So I figured we would just have them match just to show you what that would look like. And then we're going to do the same for all of these. And I'm just going to copy and paste this once again. So it's going to look like this. So it's just grabbing the data, the environment variable from the local machine. Keep in mind, they don't technically need to match, but it just makes it easier for troubleshooting purposes. And then for the Postgres database, right, we would want the password to be the same environment variable. And then we would want the database name so that we're not hard coding that one as well. And we don't want the bind mount, so we will remove that. And that's about it. So that's all you have to do. So this just gives us both a development environment and a production environment. We'll save all of that. Now, starting up Docker Compose is going to be a little bit different now because we don't use the default docker-compose.yaml file name. So if I do a docker compose, if I can find the up, docker-compose up, right, you're going to see that it throws an error, right? Because it says it can't find a docker-compose.yaml or .yaml with an A or compose.yaml or compose.yaml with an A. So it looks for only these file names. So when we have a custom file name, we have to do docker-compose. And then we pass in the -f flag for the file name. And so we provide the path to the file. So it's just in the current directory. So I could just do docker-compose-dev.yaml. And then we just do an up and then -d. And then we can start it back up. And if you want to bring up a production environment, then you would do --prod. That's the only difference. So you don't really have to do anything else other than running the different specific Docker Compose file. And the last thing that I want to change is actually in your production environment, you don't actually ever want to build the image in a production environment. Instead, what's recommended is that when you're done developing, you push the brand new image to Docker Hub, right? And then in the production environment, we just pull this image from Docker Hub. So how do we pull this image from Docker Hub? Easy. We remove this build option. Remember, this is going to be in the prod file. And we set this to be a image. And here we just set this to the name of the repository. So we just do, your username /fast API not dash app, just fast API. So whatever is essentially right here. And then if you want a specific image with a specific tag, then you would add the tag as well. And so that's all we have to do. Feel free to stop your containers now if you want. And even when you do a down, you want to make sure you do a -F. So it knows which file to actually look for. And I misspelled that. And that's going to conclude the Docker section of this course. And so I think this is going to give you a solid foundation on how to Dockerize your Fast API. Now, currently, whenever we make changes to our code, whether it's implementing a new feature or modifying the behavior of a previous feature or even fixing some bugs that we happen to catch, right, we have no idea if the changes we make break other functionality in our code. And so normally, anytime we make any changes, we then have to go into Postman and essentially manually test out every single scenario to ensure that things are working. And this isn't a very scalable solution. It's going to result in a lot of wasted hours. For every single time you make any changes to your code, you're going to have to test everything because you don't know what code you've broken by making those changes. And so this is where an automated testing library comes into play, where we can define a whole bunch of tests to test a majority of the functionality of our code. And so that way, anytime we make changes to our code, we can run our tests to see if we've broken anything. And keep in mind, obviously we can't test for everything, but we can at least test for enough things that we can catch some of the more obvious bugs. And so this section of the course is going to be dedicated to getting started with testing and really understanding the concepts of testing and seeing how we can get started with a library like PyTest. But I do want to provide one little disclaimer before moving forward. I wasn't originally going to post a section on testing for this course. And the reason for that is that I don't have much experience with testing. It's not something I do a lot of or at all, really. And so I want to make sure that you guys understand where I'm coming from when it comes to testing. And that is that, since I am not super proficient at testing, I don't really feel too qualified to actually teach it. And so what I want you guys to do take out of this section of the course is just how to get started with testing. How do you set things up? And what's the main ideas behind a test? I may not necessarily be teaching the best, most efficient way to test. I may not be using the most efficient way of testing. And there may be scenarios where I may not even be following best practices, but I want to show you guys how we can at least get some integration tests set up. And then at that point, what you guys can do is you can just forget everything else that I've taught you when it comes to testing. Once you at least have the groundwork, then you guys can, do your own research, figure out how you ultimately want to implement testing with any of your projects, and then go ahead and just run with that. So with that in mind, in the next video, we'll get started with getting PyTest installed and writing our first test. For testing, the library that we're going to be using is PyTest. So if you do a quick Google search, you can just search for PyTest, and the first result is going to take you to the documentation page for the PyTest library. And so I recommend you guys take a quick look at this just to see how it gets set up. And if you want to do a little bit of reading before we actually get started writing our first test, definitely go ahead and do that. But once we've got that opened up, what we can do is we can install PyTest. So we can just do pip install PyTest just like we would with any other package. Then once that's done, we have access to the PyTest command. So just go ahead and run PyTest and see what happens. So it prints out a few things. You notice that we can see that the test session starts. So this is when we start testing. It prints out some information about the platform that we're running on, and that's okay. We can ignore all of that. And you'll notice that it says collected 0 items. We'll talk about this in a bit, but the more important thing to look at is it says no test ran in 0.04 seconds. And this is expected. We haven't created any tests, so obviously it's not going to be able to run any tests. But to run our testing, all we have to do is just run this command, and then you'll see that PyTest will go through all of your tests, run it to verify that they all pass, and if there's any errors or anything like that, it's going to report that. So it really is as simple as that. But let's go ahead and create our test. And I want to store all of our tests inside a directory called tests. So inside the root directory of your project, just create a new folder. We'll call it tests. And technically, you can put this folder anywhere. If you wanted to put this test directory within your app directory, you absolutely could. It's a matter of personal preference. I'm just going to keep it outside of the app directory for now. And within here, I'm going to actually create a file. And this is going to store our first test. I'm just going to call this mytest.py for now. All right. And we obviously need to test a part of our code, whether that's an a route or a path operation or a function or a class. We need to test something. And right now our code is a little advanced. And when I say advanced, I don't mean advanced because anything we've done is super advanced so far. It's advanced from the perspective of testing, where we're coming in from a background of no knowledge of testing. So we want to start out with testing the simplest functions. So I'm going to actually create a brand new module and essentially create the simplest module or function that I can possibly think of. So I'm going to create a new file, call it whatever you want. I'm going to call this calculations because it's essentially going to be a bunch of functions that we use to perform certain calculations. And I'm going to define the world's simplest function, which is called add. And I think you can guess what this function is going to do. It's going to take two numbers, which is going to be type int, and it's just going to return the sum of them. So we just say return num1 plus num2. Right? And the reason, once again, is because this is going to be very simple when it comes to testing, so you guys can at least have an understanding of how to actually perform these tests. So we've got this module defined inside our app directory. And then in our tests folder, we've got our mytest.py. And we're going to define our first test. So what is a test? Well, it's really just a function. It's either a function or a method within a class. We're going to start off with just doing functions because it's just a lot easier. And we're going to call this function test_add. Why did I give it that name? Well, it's testing the add function, so I think that makes sense. And technically the naming does matter, but we'll come back to that in a bit. Now, how does this function actually work from a testing perspective? Well, it's very simple. PyTest will run through all of our tests. And when it runs through this specific test, what it's going to do is if it runs through it and there's no errors get thrown, that means the test has passed. It's succeeded. That means our code is good. If our function throws an error of any kind, it's going to consider our function or our test as failing. Then the test has failed. So how exactly does that work? It's simple. We use something called assert. And if you aren't familiar with what the assert command does in Python, anytime you assert a true value, nothing's going to happen. The code just runs. However, if you assert a false value, that means it's going to throw an error. So it's no different than raising an error or throwing an error. In Python, it's just a simple way of doing that for testing purposes. If we return something that's true, then the assert won't do anything. If we return something that's false, then it will raise a Python error. And I'm going to show you exactly how that works. So if I just say assert true, and before this, I'm just going to do a print testing add function. And then down here, I'm going to just call the test_add function right here. And I'm going to just run this as a normal Python module. So we're not going to even treat it as an actual test or anything like that. We're not even going to use PyTest. So I'm just going to call Python. And keep in mind, the command is Python on Mac, but it's Py-3 on Windows. And then we're going to go into the test directory. And we're going to call my test.py, and I'm going to show you what happens. All right, we can see it says testing add function, which is from this print statement. And then you can see the assert did nothing. So it just ran and everything's fine. And that's expected because, like I said, assert only does something when we return a false value. So if I say false now, and I run this code, take a look at what happens. Hey, look, Python throws an error. So assert is simple as that. True means nothing's going to happen. False means it's going to throw an error. And we don't have to just say true or false. We can actually pass in a condition. So if I say 1 == 1, that's going to return true, right? So technically, an assert of true won't do anything. However, if I say 1 == 2, that's going to be a false statement. And if I run that, we can see that it asserts and it throws an error. So that's how we make use of assert within our testing functions. So I'm going to remove this. And we're actually going to test out our code now. So to test out our add function, the first thing that we have to do is we actually have to import it into this file. So we're going to import it. So we'll say from, and we have to go into the app directory and the calculations module. So we'll say app.calculations, import add. And now what we're going to do is we're just going to call the add function like we normally do. And we need to give it some test data. So I want you to think of two numbers that you want to use for testing, add them up, and what is the result should it be? So I'm going to say, I'm going to do 5 and 3. And I know that this function, if it works properly, should return a value of 8 because 5 plus 3 equals 8. And so I can just take the sum, store that in a variable called sum. And what we can do is, since I know sum should ultimately be equal to 8, I can assert that. And there should be no e there. So I can say sum equals 8. So that means if our code runs fine, sum should ultimately equal 8. And if we assert 8 equals 8, that means it's going to return true and nothing should happen. Or PyTest should consider it as passing. However, if I mess up my code and for some reason the add function returns a value of 20, then when we do assert 20 equals 8, well, that's going to be false. And it's going to throw an error and it's going to consider that as a failing test because an error means a failed test. So that is the main idea behind a simple automated test within PyTest, right? You run the code with some test data and you know what the result should be because you created this test data and you just make sure that the result of the code matches with your expected result. So let's actually run our test now. So I'm going to do PyTest and let's see what happens, right? And you see the same exact thing we saw before. Once again, it says it collected 0 items, no tests ran. And so why exactly is this happening? Well, if we go to our documentation and you scroll down to this feature section, you go to the auto discovery section. And so this auto discovery section is going to explain how PyTest finds all of the tests in your code. Because it does have a auto discovery functionality where it can actually go through all of your code, all of the directories and packages, and recursively look through them and find the tests. But it looks for specific keywords. And you can see in these directories, it looks for any files that start with test. So you have to do test underscore and then some name, or some name underscore test.py. And if we go to our code, right, we name this my test. This does not match what it's going to look for. And that's why it doesn't actually find any tests from that. So let's change this. I'm going to call this, let me rename this, and I'm going to call this, how about test underscore calculations. All right, and so now if I run this, you can see that it throws an error, but I realize that, within my tests package, I do need to have the usual underscore init underscore.py to actually make it a package. So I'm going to do the same thing. I'll do underscore init underscore.py. Because of that, it wasn't able to actually import the file properly. So let's save that and let's try this again. So now if I run this, you could see that, hey, look, we collected 1 item. So I think it's safe to say that this collected 1 item probably means we have 1 test. So the number of tests equals items. And then we can see that inside the tests package, we have a module called test underscore calculations.py. And then there's a little dot. So the dot represents 1 individual test. And a green dot means good. A red dot means it failed, right? Green is pass, red is fail. And so if you have 2 tests, then you would see 2 dots. And then if the second test passed, it would be green. If it failed, it would be red. Simple as that. And so now we have successfully ran our first test. And just to make our code a little bit simpler, right, I could just, instead of having the sum variable, I can just cut this out, just paste it into here just to make it a little bit cleaner, and then we can remove all of this. And just to make sure I didn't break anything, let's run our test again. And we can see that once again, it worked just fine. Now, when it comes to the auto discovery of files, a few things to note. You don't necessarily have to follow this convention of test underscore calculations. If I actually rename this, and I call this, my underscore test, what did I call this? My test.py. All right, now if I obviously run this, it's not going to find any tests, but I can pass in the specific path or the specific module that I want to test. So if I do my test.py, then it is able to find the test. But I like to have PyTest be able to automatically find all my tests so that I don't have to specify this. So we'll rename this and go back to test underscore calculations, because it ultimately is a module that's going to be testing my calculations module. And another thing to note, the name of the test within the module also matters. If I call this, maybe something like testing underscore add, take a look at what happens. Whoops. I wanted to auto find it now, and I forgot to save it. Now, if I run this, it looks like it still works, but let me change this to just something random. Right? And so now we can see that no tests ran. So the naming of the function absolutely matters when it comes to auto-discovering tests. And you want to stick to the standard of test underscore something. And I think somewhere in this documentation, it's going to go over, here we go, test from those files, collect test items. So a test prefixed test function or method outside of a class, or a test prefixed test function or method inside a test prefixed test clause. So it's got to start with test, essentially. It doesn't necessarily have to be test underscore. That's why testing underscore add worked just fine. It does have to start with the word test. That's why if I said add underscore test, I don't think this will work actually. Shouldn't based off of their description, and it doesn't. So keep in mind that the naming does matter. And I recommend you stick to the convention of naming all of your testing modules test underscore, then the name of the module that you want to test, and then your functions test underscore, and then the name of the function that you want to test or the functionality that you want to test. Now, a couple of things to note. I'm going to run this test again, and you'll see that it doesn't really give us much detail as to what's happening, but we can pass in other flags to get a little bit more detail or to change the functionality. So if I do pytest -help, you'll see that there's a lot of options, but I think something that would probably be helpful is like a -v for verbose, and I think we should have that in here. So let's see if I can find that. Here we go. -v is increased verbosity, so we'll just do pytest-v, and let's see what happens. And so now, instead of just having a dot, it's actually going to list out the specific test that's running. So I think that's a little bit more helpful. And I usually like to run these tests with a little bit of extra verbosity, just so that I know what's happening. However, maybe in an automated environment, you don't really care about that. And the other thing to note is that we have this print statement here, but nowhere in the output do we actually see anything get printed out. I don't see testing add function anywhere in here. And the reason for that is that by default, PyTest will not actually print out any of your print statements. We have to pass in an extra flag to do that. So to see the print statements, you have to pass in -s. So now if I run this, we can see that we ran this specific test and it ran testing add function. And so keep in mind, anytime you want to print something, you got to pass in the -s flag. Okay, guys, so testing really is as simple as that. But before we go on to more complicated tests, I want to just make sure that we fully understand how this works. So we're going to create a few more dummy functions that we can use for testings. And if I go back to my calculations.py, I've already written this out, so I'm just going to paste it in here not to waste your time. But you'll see that they all essentially do the same exact thing. They just perform some sort of mathematical operation. So I've got the subtract function, which just subtracts two numbers. I've got the multiply, which adds two numbers. And I've got the divide, which just divides two numbers. So let's test this out now. The first thing that we got to do is, well, let's import all of those. So there's subtract, multiply, and divide. And let's define our function for subtracting. All right. And so just like before, I'm going to do a one-liner. So I'm just going to say assert, and we'll say subtract two numbers. What numbers do I want to subtract? How about 9 and 4? Whoops, 9 comma 4. And we know that 9 minus 4 should equal 5. So I can do assert equals 5. All right. And if I run this again, all right, we can see that both tests pass. And just to make sure that, our testing actually works, let's actually go into our code and let's essentially create a bug. So if I want to add two numbers, right, we know that's going to be num1 plus num2, but let's say, one of our moron colleagues went in and added 1, which is ultimately going to cause our function to break. And so ideally, if everything works fine in our testing, it should be able to catch this. Because if we add 5 plus 3, it's going to do 5 plus 3, and then it's going to add that extra 1. It's going to return 9. 9 equals 8 is going to assert to a false, which is going to throw an error. So if we try this out now, right, we can see that it did in fact fail. And because we set this to be verbose, we can see exactly what happened. So we ran the test add, and what happened was it asserted add 5 comma 3 equals 8. So it's asserting 9 equals 8, and that's going to throw an error. And so that way we see one failed, one passed, so the subtract function still passed because we didn't touch the code for that. So I'm going to go back and fix our bug in this case. And we're going to just set up a couple more test functions. for multiply and divide. And I can just really just copy these actually. And I'll just change this to multiply, divide, and we'll just select a couple of numbers. So let's say, and I realized, looks like that's a typo. This should be multiply with an L. All right, and we'll say 4 and 3. So when we multiply 4 times 3, that should equal 12. And for divide, we'll change the function that we're calling to be divide, and we'll do 25. So 20 divided by 5 should equal 4. And so now if I save everything, we should ideally see all 4 of our tests pass. So let's try this out again. And you don't have to use the -v or the -s flag. If you're not printing anything or you don't want to see it, you don't need the -s. And maybe you don't want the verbosity, so you could technically remove those as well. And we can see that we get 4 dots, which means all 4 of our test functions have succeeded. If you're like me, the first thing that you may have noticed is that, testing with one set of numbers doesn't seem ultra reliable, right? That doesn't necessarily assure us that the function that we wrote actually does what it's supposed to do. I would ideally like to test with a couple of different sets of numbers. And the way to do that is, well, I'm sure if you just took a guess, right, you're probably thinking, well, maybe we just copy this function, paste it. Well, that should be back here. And then maybe just call this test add 2. Maybe we don't need this print statement anymore. And then you provide the other sets of numbers. So maybe like 4 and 2 should equal 6. And then you try this out and you run this. And we can see that that worked. And technically you can do that, but PyTest provides us a simpler way of doing this. So I'm going to delete this because we don't need that. I'm going to show you how we can do this using something called parameterize. So I'm going to import PyTest. So I'll say from, actually I'll just say import PyTest. And we're going to add a special decorator from the PyTest library. So we say at pytest.mark.parameterize. And so here we can essentially provide a list of numbers that we want to use for testing and then provide what is the expected result. And so, our function takes 2 inputs, 5 and 3, and we also need to provide what is the result. So these are all the values that we're providing. We have 3 values for this specific function. So we're going to tell this specific decorator what are the 3 things that we want to provide for each test case. So in quotations, we'll do num1, num2, and then the expected value. Now, what you call these doesn't matter. It's up to you, right? But these are going to be treated like variables, essentially. So you can call them whatever you want. You can call this X. You can call this Y. You could call this result. It doesn't really matter. But I'm going to stick with num1, num2, and expected. And more importantly, take a look at how this is set up, right? Your instinct is probably to do the end quote here, and then quote here, and then quote here like that. That's not what we want. That is not how it actually works, which I don't know why they decided to do it like this, but that's just what they've chosen. So instead, you remove these, and everything should just be one big string. So that's the first argument into this decorator. The second thing is going to be a list. And it's going to be a list of tuples, and each tuple should represent one specific test case. So the first tuple, we're going to provide our test case values. So we want, what is the value of num1? So in the first test, let's say we want 3 for num1. What's the second one? That's going to be num2. So it's going to line up with what we've put here. So we'll say 3, 2. And then what is going to be the expected value? Well, 3 plus 2 should equal 5. So we just say 5. And so that's our first test. If we want to add a second test, just do comma, add another tuple. And let's just add another set of numbers. So let's say num1 is 7, num2 is 1. We know that should equal 8. And just one more test. And here I'll say 12 and 4 should give us 16. All right. And so now what we can do is we can pass these variable names into our test underscore add function. So I'll say num1, num2, and expected. All right, so you want to make sure these match up with what you've placed here, because if this was called x, then you want to make sure that this is called x. But we'll change that back. And now in our code, we want to replace all of our test values with these variables. So this is going to be num1, this is going to be num2, and this is going to be expected. And so now if I run this, and we'll just do a -v just to see more in detail what's happening. Take a look at what's happening now. We can see that test add ran, and it ran with 325, which is the first test case. It passed. Then it ran the same exact test with these values, 718. That passed. And then it ran with these values, and that ran, and it passed just fine. And then finally, all of the other functions also passed as well. So this is one way of running the same test over with multiple values without having to just define 3, 4, 5 functions and just copying and pasting. It's a little bit cleaner doing it like this. So till now, we've just tested some simple functions, and you'll see that when it comes to testing, anytime you want to test a function, it's actually pretty easy. However, when you're working with classes, it gets a little bit trickier, and it usually involves having to write a little bit more code. So I've created a simple dummy class in this case called bank account, and this represents a person's bank account. And I've already written this out because I didn't want to waste your time writing this out. So if you want to pause this video and just copy down the code so you can follow along, go ahead and do that. But let me just quickly walk you through what this specific class is doing. But like I said, this represents a bank account. So first of all, we've got the constructor. So when we create a bank account, we can create a bank account with a specific amount of money, which is going to be referenced by the starting balance value. And then it's just going to set the balance property of the bank account class to be whatever you provide. If you don't provide a starting value, it's going to default to a value of 0. Then we've got 3 different methods. We've got deposit, which means we're going to deposit money into our bank account. So all we're doing is we're going to pass in a value, and then we're just going to add it to our total balance. Withdraw is the opposite. We're going to subtract a certain amount from our balance. And then collect interest is simple. We're just collecting interest. So here we just take our balance and then multiply it by 1.1, which I guess would represent a 1% interest rate. And so those are the 3 or 4 functions, methods, if you want to count the constructor method as well, that our bank account class has. So I want to go ahead and test this out now. So we'll go to our test calculations. And first of all, we want to import our bank account class. So let's create a test for our bank account. And the first thing I want to test is, let's create a brand new bank account. Where we set the default value, to, the initial amount to be 50. So here I'll say test, and I'm just going to call this maybe test bank set initial amount. I want this to be as descriptive as possible. And so here what we're going to do is, first of all, we're going to create a brand new bank account instance. And since this test is going to test to ensure that we have actually created a brand new bank account with a certain amount of money, I'm going to provide a value. Doesn't matter what value you decide to use, but I'm going to use 50. And we'll just store this in a variable called bank account. All right. And so to test if our function actually worked, or the functionality of our constructor method actually worked, what we're going to do is we just say assert. And we want to check the bank account dot balance property equals 50, because we set the default value to be 50. And if we just quickly go back to our code, you can see that we set the starting balance, or we set our balance property to be whatever the starting balance is. It just happens to be a default of 0 if we don't provide one, but we are providing one, and that's what we're testing. So we can test this. Let's run our code now, and let's see if this worked. We can see that it did in fact work. And just to introduce a bug, maybe we set starting balance to be, -1, right? So we've broken our code. Now, if we run this one more time, all right, you can see it failed because we subtracted 1. So we're asserting 49 equals 50, which throws an error, which means we ultimately failed the test. So let me remove that bug. All right, the next thing that we want to do is let's test to make sure that the default starting balance works as well. So I'm going to create another function, And I'll call this, how about test bank underscore default amount. So in this case, we're just going to create a brand new bank account. And we're not going to pass in a value, so it should default to 0 if our code works. And then we'll store this in a variable just like we did before, and then we'll assert. I can copy this. But now it should equal 0. Okay, and let's test this out now. All right, and it looks like it worked, so great. And let's just quickly go ahead and test our last 2 functions out. Sorry, we got 3 more actually, so let's test the withdrawing functionality. So we'll do test underscore withdraw. And here we're going to initialize another bank account instance because we have to do that every time we want to test it. I'm going to give it a default value of 50. It doesn't have to be 50. Once again, you can choose whatever number you want. And we'll store that in a variable called bank account. And we'll call the bank account withdraw method. And we're going to withdraw, let's say $20. So we start out with 50, we withdraw 20, we know that the result should be 30. So if I just copy this assert statement once again, I can just change this to 30 and it should be no problem. Run this. Once again, all of our tests have passed. Let's try the deposit functionality now. So I'll create a test to test that. And I'm actually just going to copy all of this code because it's pretty much identical. You'll see that testing can become a little repetitive. We'll start out with an initial value of 50. Doesn't really matter. We'll change the method to be deposit. Maybe we want to deposit $30. So 50 plus 30 should equal 80. We test this out. Looks like everything's working. And the last thing that we want to test is the collect interest method. So let's create a function for that. We'll do test underscore collect underscore interest. And once again, I'm going to copy this code. And we'll just use it here. We're just going to change the method to interest or collect interest. Okay, so we start out with the value of 50. And so what should the interest be? Well, if I take a look at what my method actually does, it just takes the number, multiplies by 1.1. So that should give us 55, right? 1.1 times 50 should be 55. So I will say this should be 55. And let's see what happens. So if I run this, we can see that we did have one test failed, and I'm assuming it's going to be the last test, the one we just created. And we can see the test collect underscore interest failed. And the reason for that is that it looks like bank account dot balance returns a value of 55.00000001, which in Python is not the same thing as 55. So this isn't necessarily an issue with our code. It's just the way that we're comparing numbers in our test. So this is an issue with our test in this case because it's not accounting for some of the different rounding and the way that calculations occur within Python. So what we're going to do is we can just call the round method right here, and we can round it to 5 or 6 decimal places, depending on how accurate you want it to be. So it should now round it to this value, however many decimals is 5 or 6, and then convert it to an integer. So then we can compare these two because this is an integer, this is technically a float, so they're not going to be equal in that case. So now if I run this, we can see that it did successfully pass. So that's just something to keep in mind. That's why I added that little extra test case, just to make sure that, especially when it comes to those calculations, you got to make sure that you're comparing the right two numbers. If you look through all of the test cases for the bank account, you'll notice that there's some repetitive code. Right? For every single test case that we have for testing our bank account, you'll notice that we always have to initialize a bank account instance. Right? And you can see that right now, look at that. We are repeating our code across all of our tests. And when you get to more complex classes, more complex test case scenarios, right, you might have 50 tests for a single class. And we're, in this case, just repeating the same exact code for each one of them. And so when it comes to writing these tests, PyTest does provide us with some tools that we can use to minimize the amount of repetitive code. And one of those is called fixtures. And a fixture is a very simple concept. It's nothing more than a function that gets run before each one of your tests, or at least the specific test that you want. So we can create a function which does nothing more than initialize a bank account and then return it to our function that's about to run. So I'll show you how we can do that. Right, the first thing we have to do is let's create our fixture, and we can put it anywhere. I'm just going to put it here for now. But generally, you want to put it at the top of the file. Actually, I'll stick to the best practice. I'll say at pytest.fixture. And then here we create a name for our fixture. So I'll say this is going to give us or initialize us a bank account with a 0 initial value. So I'll call this 0_bank account. And so all we're going to do is we're just going to return an instance of bank account with an initial default value of 0. And then we'll create one more fixture. And this one is going to return a regular bank account with an initial value. And what value we want to give it, we get to decide. So I'll just say return bank account. And in this case, 50. All right. And so now what we can do is for all of these tests, I don't need to initialize them here because I can have these guys reference the fixture. So to assign a fixture or have a fixture get called for a function, we just pass it in as an argument. So for test bank account set initial amount, we're going to reference the 0_bank account fixture. So what exactly happens is when PyTest goes to run this test case, because it sees this as an argument into the function, it's going to, that should be a 0. Okay. But what it's going to do is it's going to call this function before it actually runs the test case. So it calls this function, and then whatever we return here, which is the bank account, gets passed into a variable called 0_bank account. And so now, instead of creating a bank account instance, I can remove this and I can reference this variable, which is 0_bank account. So let's test this out. Let's see if that broke anything. If we run this. Oh, sorry, guys. Let me undo this. I didn't mean to use this function. This is going to be for the test bank account default amount. So we want to remove this one. My apologies. And we don't need that in this one. And then this will be 0_bank account. So now all tests should pass. All right, so everything passes. But if you're still a little confused as to what exactly is happening behind the scenes or what is the order of operations, I'm going to add a few print statements. So I'm going to say testing my bank account. And then I'm going to put in a print statement inside my fixture as well, which is say creating empty bank account. And so now if we run this, I want you to take a look at the code. And I realize I have to pass in the -s flag to see the print statements. All right, so here we go. We're going to test bank set initial amount. Sorry, no, test bank default amount. And so you'll see that when we start this test, first things first is we create an empty bank account. That's that print statement for the fixture. So before the test even runs, we call the fixture because we've defined that here by saying, where is it? That it's going to be an argument into the default amount test case. Then after the fixtures run, which is just a function, we then run our actual test case, and then we get the print testing my bank account right after that. So once again, just to really drive home this point, a fixture is just a function that runs before a specific test case. That's all. But the great part is we can use the same fixture for all of our other tests. So let's go to the next test, which is setting an initial amount. And in this case, we have this fixture right here, which is the bank account one. And so I'm going to say this is going to go to bank account. So this will call the bank account fixture, and then we can remove this line. And we can just keep this here because it's referencing this variable now. And this should work now. So we run this, once again, all tests pass. And I can just do this for all of them. So I can just call the bank account fixture. And I can just remove that line. Everything else can stay the same. And the same thing here as well. And finally, for the last one, we can do that. And so now you can see that we have saved ourselves a couple of lines of code for each function. And if I run this, you can see that all the tests pass. So at this point, you're probably thinking, this doesn't really look like it saved us a lot of code or a lot of, coding out. However, there's going to be certain things that you want to do that you want to initialize before every single test of your entire application. So maybe something like setting up a test database, right? You'd want that to be set up for each single test. Having to manually do that for each test case would become very cumbersome. And then the lines of codes that you're repeating start to become a serious problem. And that's really one of the best use cases for using fixtures is something like setting up a database or setting up, some sort of email service or something that you're going to use across a lot of your tests, and then having to initialize that manually for each test is going to require a lot of work. And so that's where fixtures really help save us some time. Okay, what I want to do is I want to create one more test. And this test is going to be a little bit different. I'm going to call this test about bank transaction, maybe. And so this is going to test us both depositing money and withdrawing money in one test case so that we can have a couple of different actions on a bank account. And so just like we've done before, when it comes to setting up a fixture so that we can retrieve an instance of our bank account class, I'm going to do the same thing, but we're going to use the 0 bank account. So it starts out with no money. And then what we're going to do here is we're going to reference the 0, and we're going to start off by depositing money. And let's say I'll deposit $200. And then we can also then withdraw a certain amount of money. So now we're testing both in one specific test case. And I'll say I'll withdraw 100. And we know that we should ultimately be left with $100. So we'll do assert 0 bank account dot balance equals 100. So let's test this out. And let's see how this works. And that works as well. But what I wanted to do is, for this specific test case, I wanted to show you that we can use fixtures and parameterize so we can test multiple values like we did for this specific test case. So what I'm going to do is I'm going to copy this so that we don't have to type this all from scratch. And we're going to create a couple of different test scenarios for this specific function. And in this case, we're going to have a deposited, we're going to have a withdrew, and we can have the expected amount. And keep in mind, you're not limited to having 3 variables. You can put as many as you want. It just happens to work out that I only need 3 in this case. And then we can provide some test data. So how about the same one we have right now? We're going to deposit 200, withdraw 100, and we expect 100 in the end. We can do the same thing. How about deposit 50, withdraw 10, and we should end up with 40. And then we've got our high roller, which is sitting there with a whopping $1,200. And he withdrew, how about 200? And he's going to end up with $1,000 at the end. And so now we can pass deposited, withdrew, and expected. And now we can use deposited here, withdrew here, and then we know what the expected is going to be. So let's try this out. All right, and we can see all 3 test cases run, and in this case, all 3 test cases passed. So I just wanted to show you guys that you can use this with our fixture. So it's okay if you're using a fixture, you can still use the parameterize decorator in this case to test multiple scenarios. If we go back to our bank account class and you take a look at the withdraw method, you'll notice that right now we're not performing any check to make sure that the user has enough money. And that's not really how a bank account works, because if you have $100 and you withdraw 500, the bank's going to be like, we can't do that. So it just makes sense in our code to actually perform some sort of check. And so usually, something simple is we'll say, hey, if amount that you're trying to withdraw is greater than your balance, well, what are we going to do? Well, we're probably going to raise an exception. So I'll say raise, and we're just going to raise a standard Python exception, and we'll just say something, hey, insufficient funds in account. Right? However, if we do have enough money, then we will actually perform that operation. So this is all good. If we go to our test calculations, and we just add one more scenario in this case, but this time we deposit, let's say, only $10, and we try to withdraw, 50. Well, what is the expected scenario, the expected value? And it doesn't really matter what we put in, because this is ultimately going to, break our code, because we're raising an exception. So if I try to run this, right, it's going to fail because we're raising an exception. Right? And remember, anytime you throw an error, that's going to automatically make the test fail. So what do we do? Well, first of all, let's remove this test case, because for scenarios like this where you expect to receive an error, we need to create a different test case. So I'll call this, how about test insufficient funds? And let's say we start out with, instead of using the zero bank account, where's the, instead of using this bank account, we're going to use the zero bank account, and then we'll just try to withdraw money. So that's an easy way of testing it. So we'll say zero underscore bank account. So we'll have no money in our account. And we're going to withdraw some money. So we would do, actually, I'll just do a regular bank account. I don't know why I want zero. So we'll start out with $50, and we'll try to do a bank account dot withdraw, and we'll try to withdraw $200. So that should raise the exception. But how exactly in our test do we tell Python it's expected to receive an exception? Because right now, if we run this, once again, we're going to get the same exact error. Right? Failed. So what do? This is how you tell Python that you expect an exception. You do with, and then you call PyTest. Remember, we imported PyTest all the way at the top right here. So we'll do PyTest dot raises, and then you provide the exception that you expect. So in this case, this is just a regular Python exception. So you can just say that, and then you provide the command that you're going to run. Okay, and so that way, if this command throws an error or raises an exception, PyTest will be told to expect this. So then it would consider the test as passing. So now if I run this, we can see that the insufficient funds test passed. And if we go back to our code and actually remove this exception, we'll comment out that entire statement. What do you think is going to happen here? Right now it's failed because it did not raise an exception. PyTest is expecting an exception and we didn't raise one. So then it considers that an error in our code, because when we expect an exception, we should expect an exception. So I'll uncomment this. And now, in real code, right, you wouldn't just throw just a generic Python exception. You're going to usually create your own exception classes. So let's say we define our own exception, and I'll call this insufficient funds. And this is going to extend the exception class. And we'll just say there's no property, so I'll just say pass. And in this case, I'll say we'll raise an insufficient fund. Insufficient funds. All right, so if I make this change, what do you think is going to happen? Do you think it's going to break our code? Well, let's run this. We can see that it passed. And the reason why it passed is because insufficient funds is a child class to the exception class. So when we say we accept we expect an exception. Technically, we are getting the exception. It's just we haven't specified we specifically want a insufficient funds exception. And because this is inheriting from this class, Python says, hey, look, everything looks good. But if you did want to be as specific as possible, which is generally recommended, what we can do is I can import that exception. So we'll say from app.calculations, we can import insufficient funds. And now here we can say we expect a insufficient funds. And so now if I run this, we can see that it passes. And the benefit of this is that if for some reason our code raised another type of exception, it would consider this test as failing. So if I go back to my code and let's say that, for some reason something broke in our code and all of a sudden, instead of raising an insufficient funds error, we get some other kind of exception. And I can just simulate this by doing raise zero division error. So if you ever try to divide a number by zero, this is the exception that's expected. And so now if I run this, right, we can see that the test failed because we expected a insufficient funds exception, but we got a zero division error. And so that considers the test as failing because we've told it we've expected something, but we got something else. So it's generally best to explicitly define the exact exception that you expect so that you can make sure that, that nothing else is broken, because technically any part of your code can break and throw an error. And if it throws an error and we just try to, if we just tell, our test to expect any exception, then it may not be doing what we actually expect it to do. But we'll change this back. We don't need that anymore. Okay, so I think we have a good enough understanding on how to create a test, and I think it's time we actually started testing our application. When it comes to FastAPI automatically provides us a test client. So all we have to do is we just say from fastapi.testClient import test client. And then all we have to do is then just pass in our FastAPI instance, which is stored under the variable app, and then we can just perform any requests to our application by doing client, which is what we named the test client, and then just doing a .get or a .post or whatever, and then we can get the response, and then we can assert anything that we want just to make sure that we get the responses that we ultimately expect. And keep in mind, when you make use of this test client, right, if you take a look at the documentation, it says that you use this the same way you would any requests object. So if you've ever used the request library from Python, right, this is the same exact object. So anything you could do with requests, you can do with the test client. So you can customize the request. You can, change the HTTP method. You can add a body, a payload. You can add a authorization header. It's really just doing what Postman's doing for us, but we're going to do it through code instead of manually opening up Postman and then, figuring out which request we want to send. We're just going to do it out in Python so we can do it all in an automated fashion. But if you haven't worked with the request library, definitely take a look at this. Just take a look at how we generate requests. It's not too difficult, right? It's just request.get, or in our case, we're going to call it client, but it doesn't really matter. And then you provide the URL that you want to run this against. And then, you can add in other properties like an auth header or anything like that. So it's just about customizing your specific HTTP request. And so I'm going to create a new file, and I'm going to call this, how about test_users. This module represent tests for, creating users and getting user profiles information and things like that. And just like it shows in the FastAPI documentation, let's just copy this line right here. And then what we want to do is we want to import from our app package, go to our main file. We want to import our FastAPI instance. So we want to import this app right here so that we can actually test it. So I'll say from app.main import app. All right, so we have our app instance, and we'll just copy this line right here, which is just setting our test client to a variable called client. And so now we can run whatever tests that we want. And I think, just to keep things simple, let's start off with the simple root path that we have right here, just to test that this works. Because that way we don't have to worry about authentication or passing any other data. Let's start off with the simplest scenarios. So this is at the root URL. So we will go to our test users. And I'm just going to call this test root, because it's not really a real function or anything like that. And then here we'll say client dot. And since we are testing a specific path operation, this is a get method. So we want to send a get. So we'll do client.get. Then the URL. So we can just say /. We don't have to do localhost, because it's not technically a running server. We actually just pass the actual app instance. So we just say the root path. And then you can pass in other things like, what payload and things like that. But we'll leave that for now. Leave it empty. And we'll store the response under a variable called res. And instead of doing an assert or anything like that, for now, I just want to print out the response. All right. And if I run this, okay, so a little bit annoying thing. Right now, it's going to run all of our tests. And if you just want to test one test or one module, then I recommend you just do the same thing, except pass in the path to just your specific module, so that we don't run all of our tests all over again. So we can just run one in this case. And if we take a look at this, we can see that it just prints out a response object. Not very helpful. But if you want to see what's the actual payload, we can say .json to see what the data looks like. And so then I can run this, and we can see that, hey, look, we get message hello world. And if I wanted to grab the message property, I could say .get and then message, and it should return hello world. Let's try this out one more time. And we can see that it prints out hello world. So to test that this route actually works, what we can do is we can just do an assert. And I could say assert, and then